Welcome, my friend. If this is your first time here, this channel is made for drifting into calm sleep while learning something fascinating about the universe. Tonight, we'll quietly explore the illusion of free will, why we feel like we choose, and what science suggests about that feeling. Don't worry about holding on to every detail. Just let the words flow over you, helping your mind settle as you rest. Chapter 1. The feeling of freedom, why we think we choose. Human beings live with a constant impression of agency. At almost every waking moment, you feel as though you are selecting between alternatives. You choose what to eat for breakfast, whether to send a message or remain silent, whether to take a walk or stay seated. This sensation feels natural, obvious, and immediate. Without reflecting, you simply assume that you could have acted differently, that your life is shaped by choices springing from your own will. The feeling of free will is so deeply woven into consciousness that it seems inseparable from what it means to be human. Yet, when examined scientifically, this feeling becomes far more puzzling than it first appears. To understand why people believe they choose freely, we must first recognize that the human brain did not evolve to discover ultimate truth, but to survive in complex environments. The appearance of agency may itself have been an adaptation. Early humans faced situations demanding rapid evaluation of possibilities. A hunter had to decide whether to follow a herd or conserve energy. A gatherer had to choose between two plants with uncertain risks, and a small band had to coordinate who would guard and who would sleep. In such contexts, the ability to imagine different futures and to feel ownership over decisions would have increased survival. A mind that believed it could select among options would be more motivated to plan, to learn from mistakes, and to bear responsibility for outcomes. Over time, the illusion of agency may have become embedded in consciousness, not because it revealed ultimate freedom, but because it was advantageous. This evolutionary story finds support in modern psychology. Experiments on locus of control show that people who feel their actions affect outcomes tend to be healthier, more motivated, and more resilient. Even when control is objectively limited, the belief in agency sustains effort. In stressful circumstances, such as illness or unemployment, those who maintain a sense of free choice often cope better than those who believe events are entirely outside their control. Thus, the sense of freedom is not only a philosophical stance, but also a psychological mechanism shaping well-being. But the feeling of choice is not always aligned with reality. Neuroscientists have shown that brain activity predicting a decision can occur seconds before people report being conscious of deciding. One of the most famous studies was performed by Benjamin Libet in the 1980s. In his experiments, participants were asked to flex a finger whenever they felt the urge. Using electroencephalography, Libet detected a readiness potential in the brain that consistently preceded the reported moment of conscious intention. This suggested that the brain had already initiated the action before the participant became aware of choosing it. Later studies using functional magnetic resonance imaging extended this interval, showing predictive brain signals up to 7 or even 10 seconds before conscious awareness. These results imply that what we call conscious choice may actually be the endpoint of unconscious neural processes, not their origin. Subsequent experiments have only deepened the mystery. In some paradigms, participants are asked to press one of two buttons while brain activity is monitored. Sophisticated algorithms analyzing brain scans can predict with high accuracy which button will be pressed well before the participant declares a conscious decision. What is striking is not only the predictability, but the fact that participants insist their choices felt free and spontaneous. The gap between subjective experience and measurable brain activity is one of the strongest pieces of evidence that free will may be, at least in part, a mental construction. Despite these striking findings, the interpretation remains debated. Some argue that readiness potentials reflect only the preparation for possible movement, not a decision itself. Others suggest that conscious will may still play a role in vetoing or modifying actions at the last moment. This so-called free won't hypothesis proposes that while unconscious processes initiate behavior, consciousness retains a capacity to suppress it. But even if this is true, it still paints a picture of limited agency. Rather than freely creating actions, consciousness may be more like a gatekeeper, approving or rejecting impulses that arise elsewhere in the brain. To appreciate why the brain generates this sensation of ownership, we must consider its architecture. The nervous system is a massively parallel network with billions of neurons firing and influencing one another in patterns shaped by genetics, experience, and environment. These patterns are not random, they follow biophysical rules. Neurons fire when membrane potentials reach a threshold, neurotransmitters diffuse across synapses, and circuits strengthen or weaken through plasticity. Out of this complex machinery emerges the sense of a unified self making choices. Yet this unity is a construction. Split brain studies, where the corpus callosum connecting the two hemispheres is severed, reveal that the brain can generate conflicting actions and still produce a narrative of coherence. Patients may act with one hand under the influence of the right hemisphere and explain the action using the left hemisphere's language center, even when the explanation has no relation to the true cause. This demonstrates that the conscious story of why we act is often invented after the fact. Different brain regions contribute to this constructed story. The prefrontal cortex is central for weighing consequences and inhibiting impulses, while the basal ganglia play a major role in initiating movement. Dopamine systems signal reward predictions, shaping preferences often before awareness arises. When dopamine surges in anticipation of an outcome, you may feel drawn to act in ways that feel voluntary, but are in fact driven by neurochemical bias. The anterior cingulate cortex monitors conflict and errors, giving you the feeling of inner struggle when choosing between options. Together, these systems create the dynamic texture of decision-making, one in which much occurs before the conscious self narrates its role. The brain's need to generate coherent explanations is so strong that it routinely attributes causes incorrectly. Psychologists call this confabulation. When people are subtly influenced to pick one option, they often provide elaborate reasons unrelated to the actual cause. For example, a person exposed to a subliminal cue that biases them toward choosing a word may later justify their choice by saying it just felt right. The real cause lies hidden, yet the sense of freedom persists. This suggests that the experience of agency is not a transparent window onto decision-making, but a constructed narrative that maintains a stable sense of self. Cultural factors reinforce this narrative. Across societies, people are taught that they are responsible for their choices. Religious traditions frequently emphasize the importance of free will in determining moral worth. Legal systems rely on the assumption that individuals could have acted differently when they committed a crime. Social interactions are structured around praise and blame, both of which depend on attributing agency. Even languages encode this bias. Many languages distinguish carefully between intentional and accidental actions. Saying, "I broke the vase" versus "the vase broke" communicates different degrees of responsibility. This linguistic framing strengthens the impression that agency resides in the individual. Interestingly, not all cultures conceptualize free will in the same way. Cross-cultural psychology has shown that Western societies, particularly those influenced by individualism, place a stronger emphasis on personal choice than many collectivist cultures. In societies where community and fate play larger roles, the experience of free will may be less pronounced. People may view their actions as more tightly bound to social roles, traditions, or divine will. Nevertheless, even in collectivist settings, individuals still report subjective feelings of agency in daily decisions. This suggests that while the interpretation of free will varies, the underlying sensation of choosing is likely universal, rooted in brain processes common to all humans. The history of philosophy reflects these tensions. Ancient Greek thinkers, such as Democritus, argued that all events are determined by necessity, while Aristotle emphasized the role of deliberation and voluntary action. In the early modern era, figures like René Descartes believed in the soul's power to choose independently of physical determinism. Later, philosophers such as David Hume described free will as compatible with determinism, as long as freedom is defined as acting according to one's desires without external constraint. This compatibilist position remains influential today. By contrast, libertarian philosophers maintain that genuine free will requires actions not fully determined by prior causes, while hard determinists argue that no such freedom exists. The physics of the universe further complicates the question. Classical mechanics, as articulated by Newton, describes a deterministic world. Given the state of the universe at one moment, its entire future is fixed. Under this framework, every thought and action would be the inevitable outcome of prior states. The metaphor of the clockwork universe suggested that free will was impossible, a mere illusion produced by ignorance of the underlying causes. Later, quantum mechanics introduced indeterminacy at the level of particles. Some have argued that this randomness opens space for free will. Yet randomness is not the same as choice. A decision determined by random quantum fluctuations is no freer than one determined by classical laws. Agency requires more than unpredictability. It requires authorship, which physics alone cannot provide. Chaos theory adds another subtle layer. Even in deterministic systems, tiny differences in initial conditions can lead to enormous differences in outcomes. Weather patterns, planetary orbits, and even certain neural processes can behave chaotically, meaning they are highly sensitive to minute variations. To an observer, such systems appear unpredictable, and unpredictability can feel like freedom. But chaos is not freedom either. It is complexity born of lawful dynamics. Your brain may harness such complexity to generate behavior, but unpredictability to others does not guarantee genuine free will to you. Still, our subjective sense of freedom persists. One explanation is that the brain interprets time as a flow from past to future, and within that flow, it generates the image of branching possibilities. You stand in the present and imagine alternative futures, each contingent on your choice. This creates the feeling of selecting among them. But if time itself is an emergent feature of consciousness, as some physicists and philosophers argue, then this branching may be illusory. All that exists might be a fixed space-time block, with consciousness moving through it, like a reader moving through the pages of a book. From this perspective, Your experience of choosing may be akin to your experience of turning the page, an act that feels free but unfolds within a predetermined structure. Another dimension to the illusion of freedom arises in how memory works. When you recall past decisions, you reconstruct them from fragments, often reshaping the narrative to fit your current understanding. This reconstruction strengthens the impression that you once chose differently and could do so again. But memory is not a perfect record. It is an evolving story. By continually rewriting the past, the brain sustains the belief that it authored those moments. The reliability of this feeling is questionable, yet its power is undeniable. Despite mounting evidence that conscious free will may be limited or illusory, it remains central to human meaning. People organize their identities around the choices they believe they have made. They speak of being proud of their decisions, regretful of their mistakes, or hopeful about future possibilities. This narrative coherence gives life its arc. Even if neuroscience reveals that unconscious processes initiate actions, the conscious story of choosing becomes the thread that ties together experience. To strip away that thread would be to unravel much of what makes life intelligible. In this sense, the illusion of freedom may be indispensable. It motivates individuals to strive, to imagine, to hold themselves accountable. It allows societies to function, binding people together with shared expectations of responsibility. It may not grant metaphysical independence from causality, but it grants psychological and cultural stability. Perhaps that is why the brain evolved to create it so vividly. And yet, standing at the intersection of science and experience, one is left with a quiet paradox. If every action is caused by prior states of the brain and the universe, then the sense of freedom is indeed an illusion. But if that illusion drives us to live, to create, to connect, and to find meaning, then it is an illusion worth keeping. Perhaps free will does not exist as we imagine, but the story of freedom, the feeling that we choose, may be the most human story of all. Chapter 2. Determinism in Physics, the Clockwork Universe. In the centuries when classical physics reached its most confident form, many scientists and philosophers came to believe that the universe was a vast, perfectly ordered mechanism. If one could know the precise positions and velocities of all particles at a given instant, and if one also knew the forces acting upon them, then, so the reasoning went, the entire future would follow with necessity. This picture did not emerge from speculation alone. It was built piece by piece from the striking successes of mechanics, astronomy, and electromagnetism. It was a picture of law without exception, an ontology in which randomness signaled ignorance rather than an intrinsic feature of nature. In this world, the language of cause and effect seemed sufficient to account for everything from planetary orbits to the fall of a pebble, and it was natural to ask whether anything, least of all human choice, could escape the grip of those laws. Newton's laws of motion supplied the first robust architecture for this view. The second law connected forces to acceleration, making it possible to take a snapshot of the world, positions, velocities, and forces, and then compute the next snapshot and the next in a continuous unfolding. The same principles explained falling apples and circling moons, unifying terrestrial and celestial motion under a single theory. With gravity described by an inverse square law, the movements of celestial bodies were no longer mysteries embedded in myth, but calculable trajectories. The ellipse of a planet around the sun was not merely observed, it was derived. To many, this felt like a revelation. Nature could be read as a book written in mathematics, and its sentences had a grammar that never stuttered. The power of this picture was dramatized in the solar system. When small discrepancies in Uranus's orbit were noticed, they did not prompt appeals to mystery. Instead, using the deterministic equations of mechanics, astronomers inferred the existence of a farther planet tugging gently on Uranus. Neptune was later observed near the predicted position. The achievement was a parable for an age. If something looked unpredictable, it was because some cause had not yet been measured. The law itself remained intact. Even anomalies, Mercury's anomalous precession among them, were invitations to refine the law, not to abandon the deterministic ideal. Prediction and retrodiction worked in tandem. The past and the future were, in principle, equally accessible to calculation. Determinism's philosophical emblem became Laplace's demon. Imagine, Pierre-Simon Laplace proposed, an intellect vast enough to know the positions and velocities of all particles, and to compute without error their interactions. For such an intellect, the future and the past would be present at once. No uncertainty would remain, not because the world had become less complex, but because the demon's knowledge would be complete. In the demon's gaze, probability would collapse into fact. For many, this thought experiment distilled the spirit of classical mechanics. The world advances by strict necessity along a single track laid down by its initial state and the inviolable laws that govern it. It is important to understand what this picture claims and what it does not. Determinism, in the classical sense, does not require that human beings can actually predict everything. It requires only that, given the same initial conditions and the same laws, the same outcome follows. Practical limitations on measurement or computation do not weaken determinism's metaphysical claim. Even if no human instrument could ever know the exact state of the world would nonetheless evolve along a unique, law-governed path. Thus, the difficulties of prediction under noise or chaos do not, by themselves, refute determinism. They mark the boundary between what is predictable to us and what is fixed by nature. Classical mechanics was not the only pillar supporting this conviction. The Lagrangian and Hamiltonian formulations of mechanics recast motion into elegant principles. Systems evolve along paths that make certain quantities extremal, and time evolution can be described as a flow in phase space, where points representing complete states move along well-defined trajectories. Maxwell's equations for electromagnetism added still more structure, showing that electric and magnetic fields evolve in time according to deterministic partial differential equations, and that light itself is an electromagnetic wave. Taken together, these theories suggested that both matter and field were subject to laws that left nothing genuinely open. Specify the state, and the state at the next moment is determined. The marriage of mechanics with astronomy made determinism a public spectacle. Comets returned on schedule, tides rose and fell in patterns that could be charted, and the precession of Mercury's orbit, though not fully explained by Newtonian gravity, yielded eventually to a new but still deterministic theory in general relativity. Each success fed a narrative in which the universe resembled a grand clock. Exquisitely complex, perhaps, but nonetheless mechanical. When people spoke of laws of nature, they were not speaking loosely. They meant that nature actually obeys rules that are universal in scope and unbroken in application. Beneath this confidence lay deep mathematical ideas about initial value problems. In many classical systems, specifying positions and velocities at one moment determines the state at all later moments. This is the Cauchy problem in mathematical physics, Given initial data, a unique solution exists, where the conditions required by existence and uniqueness theorems were satisfied. The world's evolution was mathematically pinned down. Even where proofs were unavailable, experience suggested that nature behaved as though such uniqueness held, and engineers built bridges, machines, and later electronics on that faith, repeatedly vindicated by practice. Boltzmann's statistical mechanics introduced an apparent wrinkle that, paradoxically, ended up reinforcing determinism. At the microscopic level, a gas could be modeled as an enormous number of particles interacting via deterministic forces. Yet at the macroscopic level, we speak of temperature, pressure, and entropy, quantities that emerge from averages over countless microstates. The second law of thermodynamics, which says that macroscopic entropy tends to increase, is statistical, not absolute. But crucially, the statistics rest on an underlying deterministic microdynamics. Probabilities reflect ignorance of which microstate the system occupies, not any failure of law. Liouville's theorem shows that the volume occupied by an ensemble of microstates in phase space is preserved under Hamiltonian evolution, while coarse graining introduces the apparent arrow of time. On this view, randomness is a tool of description, not an ontological feature of reality. A sophisticated challenge to the simplistic image of predictability came from Poincaré and the study of dynamical systems. He showed that even deterministic equations can lead to behavior so sensitive to initial conditions that long-term prediction becomes practically impossible. This is the root of what later came to be called chaos. Exponential divergence of nearby trajectories in phase space. The weather, a double pendulum, and the three-body problem all exemplify this phenomenon. Yet chaos is not indeterminism. The equations remain exact. It is our knowledge of initial conditions that is fragile. The distinction matters. If one confuses unpredictability with indeterminism, one mistakes an epistemic limitation for a change in the underlying metaphysics. If the classical picture left no room for freedom, it was because it construed the world as a closed causal web. Every event was the effect of prior causes and the cause of subsequent events. Within such a web, the space for spontaneity shrinks to a rhetorical flourish. One may say, I could have done otherwise, but on the deterministic view this amounts to, if the world had been different in certain precise ways, a different outcome would have followed. The counterfactual contains the concession. There are no causal gaps into which a free choice, conceived as an uncaused originator, could wedge itself. Everything that happens flows from what has already happened and the laws that govern the flow. This closure was made more persuasive by how far the deterministic net could be cast. Consider rigid body motion, fluid dynamics, and elasticity theory. Each domain admits differential equations that, at least in principle, determine time evolution given initial data and boundary conditions. Engineers apply Navier-Stokes equations to model air over a wing. Those solutions are complex and turbulence remains a formidable mathematical problem. The spirit remains deterministic. In celestial mechanics, perturbation methods allow the calculation of subtle effects in multi-body systems. In electromagnetism, boundary value problems yield unique field configurations. Determinism became the default expectation, and when models required stochastic terms, they were treated as placeholders for untracked causes. There were, to be sure, intriguing edge cases. Philosophers have pointed to cleverly constructed scenarios in Newtonian mechanics, such as the so-called Norton's dome, where the mathematical conditions guaranteeing uniqueness fail, allowing a particle at rest to begin moving without cause. These models are deliberately pathological, exploiting breakdowns in the smoothness assumptions that ordinarily underwrite existence and uniqueness theorems. Whether they amount to a real challenge to classical determinism depends on whether one takes such idealized systems to be physically realizable. Most physicists regard them as mathematical curiosities that map the boundaries of the theory's assumptions rather than counterexamples that overturn the core picture. If one asks why physics once seemed to leave no room for freedom, the answer lies not only in the equations but in the guiding ideals of the scientific enterprise. The point of a law is to compress nature's behavior into a form that allows reliable inference. Each successful compression invites a bolder thesis. The behavior was compressible because it was constrained, and it was constrained because it was determined. The triumphs of celestial prediction, the engineering of machines, and the harnessing of electricity all trained the scientific imagination to look for constraints so strong that, when fully known, they would bind events to a unique path. Freedom, in this picture, was not the power to break the chain, but the experience of moving within it. General relativity, when it arrived, did not dismantle this ethos. It reshaped space and time into a dynamic geometry, but it preserved the spirit of determinism under appropriate conditions. Given data on a space-like slice of a globally hyperbolic spacetime, Einstein's equations determine the future development of that data. The gravitational field and the distribution of matter evolve together according to equations that, while nonlinear and challenging, are no less law-bound than their classical predecessors. Determinism can fail in spacetimes with pathologies, such as Cauchy horizons in certain exact solutions. But those are special cases that illuminate the structure of the theory rather than its default behavior. The overall lesson remains that physics seeks initial data and laws sufficient to fix what comes next. One might protest that human choice feels unlike the motion of planets or the oscillation of fields. Surely consciousness introduces something new. The classical determinist replies that this is a difference in complexity and point of view, not a difference in kind. The brain would be, on this picture, a physical system obeying the same laws as everything else, albeit one with staggering intricacy. If one could, in principle, specify the positions and momenta of all relevant particles and the states of all fields in a brain, then its future states would be fixed as well. The felt freedom would be an artifact of limited perspective, an inner narrative told from within a system whose operations are neither accessible in detail nor controllable by the narrator. Laplace's demon dramatizes this conclusion in a way that has proved philosophically resilient. The demon is not limited by noisy instruments, finite computers, or human biases. It represents the ideal of complete information and unbounded calculation. The thought experiment thus isolates the metaphysical claim from the practical one. It says, even if no creature could actually perform the computation, the universe would nevertheless be computable in principle, because its state at one time fixes its state at all times. Critics have probed the demon from many angles, questioning the physical possibility of such knowledge, the thermodynamic cost of storing it, and the computational burden of performing the calculation. But those critiques address the feasibility of the demon, not the determinism of the laws the demon exploits. There is an additional reason determinism once felt natural: reversibility at the microscopic level. In classical Hamiltonian mechanics, if one knows a system's state at a given time, one can evolve the equations forward or backward uniquely. The film can be run in reverse and still portrays a lawful process. Irreversibility enters at the macroscopic scale through coarse graining and the special initial conditions of our universe. not because the microscopic laws pick a preferred time direction. This reversibility harmonizes with determinism by suggesting that nothing is lost as time flows. The state carries forward all the information needed to reconstruct its history as well as to anticipate its future. Of course, time-symmetric equations alone do not compel a deterministic reading. One could imagine laws that are reversible but still include stochastic elements. But in the classical framework, such stochasticity typically functions as a modeling convenience rather than an ontological thesis. When engineers treat thermal noise as random, they mean that its microscopic causes are too numerous to track, not that anything uncaused is happening. The pragmatic use of randomness thus coexisted comfortably with the metaphysics of law-bound evolution. When the 20th century introduced quantum theory, with its apparent indeterminacy, it did so against this backdrop of confidence. That is why early quantum debates were so charged. They threatened not only a set of equations, but a worldview in which the explanatory ideal was complete causal determination. Before quantum mechanics, the ethic of explanation was to dig for hidden variables whenever probabilities appeared. If a roulette spin looked random, one imagined a more detailed mechanical story about friction, impacts, and air currents. If a gas behaved statistically, one envisioned moving particles whose deterministic collisions produced the aggregate. This habit of mind made the quantum turn not merely surprising, but disorienting. But this chapter is about the classical stance itself, and it is worth appreciating its intellectual virtues as well as its limitations. Determinism gave scientists and engineers a stable platform on which to build. It oriented research toward discovering laws precise enough to make predictions, and toward improving measurement so that predictions could be tested. It disciplined explanation by refusing to allow mysteries to masquerade as causes. It offered a picture of nature in which everything, from the swing of a pendulum to the orbit of a planet, had a reason that could, at least in principle, be spelled out without remainder. Why, then, did this style once seem to leave no room for freedom? Part of the answer is conceptual. If every event is caused by prior events in accordance with fixed laws, then there is no remainder for a free choice to be. Freedom, in the strong sense of an uncaused initiator, would amount to a break in the chain. Classical physics offered no mechanism for such a break. The other part is psychological. The success of prediction creates a visceral sense that the world is closed. When a comet arrives on the night predicted decades before, one feels not only the power of mathematics, but the inevitability of nature. Habit makes metaphysics. We come to see necessity wherever prediction succeeds. It is easy to mistake this message for a final verdict. Even within classical physics, however, nuance is necessary. Determinism describes how states map to states under laws. It does not, by itself, tell us which description level is most appropriate for understanding complex systems. In practice, scientists construct effective theories that ignore countless micro-level details while capturing reliable patterns at the macro level. These effective descriptions often include probabilistic elements, not because nature is indeterminate, but because the variables that matter for our purposes do not include every microscopic degree of freedom. In this sense, classical physics leaves room for explanations that are not purely microphysical without abandoning the determinist core. The clockwork image also invites a reflection on humility. If the world is law-bound, then our task is to learn those laws and apply them responsibly. But the very complexity of lawful systems means that foresight has limits. Determinism does not grant omniscience to finite minds. It imposes responsibility without guaranteeing control. The history of technology shows both the power and the peril of acting in a lawful world. We can send information around the planet in milliseconds, and we can also amplify small errors into large failures when we rely incautiously on models at the edge of their domain. Viewed against this classical background, the modern debates over free will take on a different tone. If the brain is a physical system within a causally closed universe, then the old image of a self standing outside the natural order cannot be sustained. The question becomes whether meaningful notions of agency and responsibility can be reconciled with causal closure, not whether we can puncture the chain with spontaneous acts. Many have argued that they can, by relocating freedom from metaphysical exemption to psychological capacity. To act freely is to act from reasons that reflect one's character and understanding, even if those reasons arise within a determined world. Classical physics, taken seriously, does not settle this debate, but it does set its stage. From a certain contemplative distance, the Clockwork universe has a gentle melancholy. It suggests a cosmos where every ripple follows from earlier waves, where even the turning of a thought is a continuation of a motion begun long before. And yet, within that continuity, life composes its own meanings. We read the script we did not write and still find ourselves moved by the story. If the stars and our neurons trace lawful arcs, the wonder is not diminished, it is reframed. The calm of the night sky is perhaps the quiet confidence of a universe that keeps its promises. Chapter 3. The Quantum Escape. Does uncertainty mean freedom? For those who feel the weight of a lawful universe, quantum mechanics has often appeared as a small door left ajar, an escape route from the rigid architecture of classical determinism. If Newtonian dynamics seem to fix the future once and for all, the quantum description seems to reinstate contingency at the most fundamental level. Electrons do not traverse definite paths between measurements. Radioactive nuclei do not decay at predetermined moments. Photons encountering a beam splitter do not carry a tiny gear that decides which port they will exit. All we can do is assign probabilities to outcomes and then watch as the world draws from the distribution. It is tempting to see in that draw a space for freedom, as though the universe were pausing to ask, which way, before continuing on. But randomness is not agency, and uncertainty is not authorship. To understand why, one must look closely at what quantum indeterminacy asserts, what it forbids, and what it leaves unchanged. The cornerstone of quantum indeterminacy is the rule that connects the mathematical object we call the wave function to observed frequencies of outcomes. If a system is prepared in a given state, and then an observable is measured, the theory yields probabilities for different results. These probabilities are not, on the orthodox view, a bookkeeping device for ignorance about underlying variables. They reflect genuine chances in the world. When a single atom emits a photon, the timing of the emission is not secretly fixed by some hidden clock we simply fail to read. The best description is that the event occurs with a certain rate, and individual emissions scatter randomly in time around that expectation. When a spin-half particle is measured along an axis after being prepared in a superposition relative to that axis, the outcome is not determined in advance in any way compatible with locality and other classical intuitions. The distribution is set by the state, but the particular result is not. This assertion of intrinsic chance is not a philosophical embellishment added after the fact. It is forced on us by experiments. The deepest of these constraints is encoded in the family of results around Bell's theorem and the violations of Bell inequalities observed in laboratories worldwide. If one assumes that measurement outcomes are determined by pre-existing local properties, and that space-like separated choices cannot influence one another faster than light, one arrives at inequalities that the correlations between entangled systems must satisfy. Quantum mechanics predicts and experiments observe that these inequalities are violated. One can respond by giving up locality, by giving up the idea that outcomes are fixed by such properties, or by weakening some other assumption. What one cannot do is maintain the full classical picture of hidden causes that roll forward deterministically and locally to yield each outcome while still matching the data. Whatever story one tells, something has to give, and the simplest concession is that some measurement outcomes are not determined by variables that existed in the past light cone in any classically acceptable way. The measurement problem complicates the narrative. Between measurements, quantum states evolve smoothly and deterministically according to the theory's unitary law, a rule as exact in its way as any equation of classical physics. But whenever we perform a measurement, we do not observe superpositions. We observe definite outcomes. The standard story speaks of collapse, a non-unitary update in which the wave function is projected onto an eigenstate corresponding to the observed result, with probabilities fixed by the state before the measurement. This dual mode of evolution, unitary between measurements, stochastic and discontinuous at measurement, raises deep questions about what a measurement is and why it should be special. Decoherence theory has explained why, under ordinary conditions, interference between different outcome branches becomes negligible, and why macroscopic records become stable in preferred bases. It shows how classicality emerges from entanglement with the environment. But decoherence alone does not pick a single outcome. It explains why we do not see interference, not why the needle points left rather than right on any given run. At some level, whether fundamental as in collapse models or perspectival as in many worlds, probabilities remain. Against this background, it is straightforward to state the central point. A random event, no matter how deeply woven into the fabric of physics, does not constitute a free choice. If a detector clicks now rather than a millisecond later because of a fundamentally stochastic decay, the timing is not the product of anyone's decision. If a single quantum fluctuation tips a chemical reaction in one direction rather than another, that is not a triumph of will, but a reminder that nature, in some respects, plays dice. Freedom, if it exists in a sense worth caring about, involves control, the ability to act for reasons, to shape outcomes in light of goals and information. Randomness, by contrast, erodes control. Injecting quantum noise into a process does not make it more yours. It makes it less predictable. This distinction matters because quantum talk has been enlisted again and again to defend a metaphysics of freedom by gesture rather than by argument. The gesture points from determinism to indeterminism and then pronounces the human will vindicated. Yet the arrow collapses two separations that must be kept clear. The first is the separation between epistemic unpredictability and ontic indeterminacy. Chaos in classical mechanics produces the former. Quantum mechanics may produce the latter. In neither case does unpredictability become agency. The second is the separation between microphysical law and macro-level organization. Even if some micro-events are uncaused in the classical sense, the emergence of purposive behavior depends on structures that integrate information and respond to reasons across scales. Those structures can operate with or without micro-level indeterminism. They do not derive their normative force from randomness. Different interpretations of quantum mechanics dramatize the distinction in complementary ways. In the Everett or many worlds interpretation, the state of the world never collapses. The evolution is exact and universal. Measurement correlates the state of a system with the state of an apparatus and ultimately with the state of an observer, producing branches in which different outcomes are realized. From inside a branch, an observer experiences an outcome as if it were selected probabilistically, and decision theory can be used to justify using the usual quantum weights to guide rational action. But metaphysically, all outcomes occur. If one had hoped to rescue freedom by locating it in the selection of a unique future, many worlds offers no refuge. The multiplicity is deterministic. What we call chance is self-locating uncertainty about which branch one will find oneself in after measurement. Agency in this picture is evaluated within branches where observers act for reasons and pursue goals, not at the point of branching, where there is no singular event to be caused by a will. Pilot wave theories, exemplified by de Broglie-Bohm mechanics, offer a different path. Here, particles possess definite positions at all times and a guiding wave, evolving according to the standard unitary law, steers their trajectories. The theory is explicitly deterministic. Given the initial configuration of particles and the wave function, all future configurations are fixed. The price of this clarity is radical non-locality. The velocity of one particle can depend instantaneously on the positions of distant others through the wave. From the standpoint of freedom, pilot wave restores the classical lesson rather than overturns it. If one wants a version of quantum theory in which the world is once again fully determined, including the motions inside brains, this is it. The reintroduction of determinism does not, by itself, settle questions about agency. It locates them where classical physics did, in the relationship between reasons and causes in systems whose behavior is fixed by initial conditions and law. Objective collapse models explicitly add stochastic dynamics to produce real collapses. Microscopic superpositions persist briefly, but macroscopic superpositions are rapidly reduced, yielding single outcomes with probabilities approximating the usual rule. This is indeterminism written into the law. Yet the randomness is still brute. The stochastic terms are not governed by agents, and the collapses do not occur in response to intentions. They occur according to rates and amplification mechanisms specified by the theory. If one hoped that indeterministic law would grant a lever to the will, collapse gives no such handle. It delivers a world in which some events are not determined by the past, but it does not deliver a world in which those undetermined events are determined by us. Contextuality adds another layer. The Kochen-Specker theorem shows that non-contextual hidden variable assignments for quantum observables are impossible in Hilbert spaces of dimension 3 and higher. Roughly, one cannot pre-assign values to all observables in a way that is independent of which other compatible observables are measured alongside them. The value an observable takes can depend on the measurement context. This feature is alien to classical intuitions, and it cross-cuts simple determinism versus indeterminism narratives. What it does not do is confound the distinction between randomness and choice. That an outcome is contextual does not make it authored, any more than a coin's landing depends on how it is flipped makes the result an act of will. The interface between quantum events and macroscopic behavior is mediated by decoherence. When a quantum system becomes entangled with its environment, Interference between components of the state in certain bases becomes negligible. The reduced state of the system looks like a classical mixture in a preferred basis, often called the pointer basis, and stable records form. As a result, the world at our scale exhibits robust regularities that can be modeled effectively by classical stochastic dynamics informed by underlying quantum structure. This filtering has a philosophical consequence. Even if micro-level events are intrinsically random, the macro-level patterns we care about, organisms regulating their internal states, brains integrating sensory input over time, societies coordinating behavior, are constrained by energy flows, feedback loops, and control architectures. The role of quantum indeterminacy in those patterns is more like the hiss of a radio in a storm than the voice of a conductor. Nevertheless, some have speculated that quantum noise could be the seed of behavioral variability. In models of decision-making that treat neural activity as an evidence accumulation process drifting toward a boundary, small fluctuations can shift the moment at which a threshold is crossed. If those fluctuations include contributions from quantum-scale events amplified through biophysical nonlinearities, then quantum chance will ripple into action times. This is an interesting possibility. It does not, however, turn randomness into freedom. If a person presses a button now rather than 200 milliseconds later, because of microfluctuations, the timing is less controlled, not more. Agency is the ability to modulate action in light of goals and reasons, to delay or hasten because one understands what is at stake. Noise is orthogonal to that capacity. Theories that try to save freedom by sprinkling quantum dust into neurons mistake unpredictability for authorship. Quantum randomness has been put to work in a way that underscores its impersonality. Modern cryptography uses quantum processes to generate random numbers certified by the very features, violations of Bell inequalities and device-independent protocols that signal the lack of classical hidden variables. The trust we place in these numbers comes from our inability, even in principle under widely accepted assumptions, to predict them better than chance. The engineer's satisfaction is the philosopher's warning. The very properties that make quantum randomness valuable in securing communications make it useless for conferring control. We rely on it precisely because no one, not even an idealized adversary with complete knowledge of our apparatus, can will the sequence to be otherwise. If randomness is not freedom, perhaps indeterminism removes a different obstacle. The claim that if the future is fixed, then responsibility is impossible. One can concede the point and still deny the inference. Responsibility is a relation between agents and actions, assessed within social and psychological frameworks. Dislodging the vision of a single fixed future does not automatically install liberty. It merely shows that alternative futures are consistent with what has come before when the laws are probabilistic. The space thus opened needs to be filled by capacities that do not ride on chance, the ability to deliberate, to foresee, to commit, to learn. The quantum loosening of necessity does nothing by itself to build those capacities. If anything, it underlines the difference between a world that leaves room for them and a world that bestows them. The association between quantum theory and free will has sometimes rested on more specific proposals. One is that consciousness causes collapse. If observations reduce the state, then perhaps the mind plays a constitutive role in producing definite outcomes, and perhaps by choosing what to observe and when, it selects among futures. The scientific difficulty with this line is that observation, in practice, can be replaced by interaction with a macroscopic apparatus and its environment, No special mental ingredient is required to obtain definite records. Moreover, collapse theories that render the reduction physical rather than mental already supply the single outcome story without invoking minds. Another proposal imagines orchestrated objective reductions within biological structures, suggesting that gravity-related collapse dynamics in microtubules could underwrite moments of conscious choice. The speculative nature of the postulated coherence and the absence of decisive empirical support make this a tenuous basis for a theory of freedom. Even were the dynamics correct, their stochasticity would not, by itself, amount to agency. It is easy to be misled by language. Physicists speak of choosing a measurement basis, of preparing a state, of post-selecting outcomes. These are acts by scientists and their machines. They are decisions in the ordinary sense, shaped by goals, training, and experimental constraints. But the physics does not smuggle the scientist's agency into the electron. The electron does not choose an eigenvalue. It participates in an interaction whose statistics are given by the theory. The word choice is a homonym across levels, not a bridge. What, then, is the correct moral to draw from quantum indeterminacy for the philosophy of action? It is that the failure of determinism at the micro level is orthogonal to the presence or absence of genuine agency at the macro level. One can have a deterministic microphysics and meaningful agency if the relevant higher-level organization implements reasons-responsive control. One can have an indeterministic microphysics and a lack of agency if the higher-level organization is absent or disabled. Quantum theory neither guarantees freedom nor forbids it. It revises the ontology of the small and, through decoherence, explains the stability of the large. The work of understanding agency is done in the middle, where systems with memories and goals navigate constraints using information. A subtle point deserves emphasis. Even in a world with intrinsic chance, probabilities are structured. They depend on the quantum state and the operators associated with measurements. They conserve quantities and respect symmetries. They are not blank chaos, but patterned likelihoods. When one hears that an event is random, one imagines sky-blue noise. Quantum chance is not like that. It is heavily constrained and exploitable for reliable technologies. The same apparatus produces the same long-run frequencies. The same interference pattern builds up under the same conditions. The calculus of chance is strict. Freedom, if it is to be found, must make peace with that strictness rather than rely on its absence. Another subtlety concerns locality and information. Entangled systems exhibit correlations that cannot be simulated by local hidden variables, yet these correlations cannot be used to send signals faster than light. The no-signaling theorem guarantees that while measurement choices in one wing of an experiment influence joint statistics, they do not enable controllable communication of a message. This balance, non-local correlation without superluminal signaling, protects causal structure while denying classical stories. It is a reminder that quantum oddity often lives in the architecture of correlations rather than in capricious violations of order. The correlations are strange, but they are law-like. They can surprise, but they cannot be harnessed to dictate outcomes by fiat. A final physical theme is the scaling of quantum effects into the classical world. Quantum chaos and the so-called Ehrenfest time mark the duration over which semi-classical approximations track classical trajectories before wave packet spreading and interference wash out the classical picture. In macroscopic systems at ordinary temperatures, this time is extremely short, and decoherence is extremely rapid. The consequence is that quantum indeterminacy, while omnipresent in principle, is funneled through environmental interaction into patterns that are stable enough to support clocks, computers, and biological organisms. This funneling does not banish chance, it domesticates it. What emerges is a world that is reliably navigable, in which agency, if it exists, operates by exploiting regularities, not by appealing to singularities. All of this returns us to the chapter's title question with a clearer perspective. Does uncertainty mean freedom? It means only that the universe, at microscopic scales, is not a book whose next word can be deduced from the previous words with certainty under the constraints that once seemed obvious. It means that some events have no deeper why than the measure assigned by a complex amplitude. It means that even perfect knowledge of a state vector leaves the next recorded outcome open. But freedom, in any rich sense, is not the openness of a slot machine. It is the capacity of a system to act in light of reasons, to integrate information across time, to pursue ends while remaining sensitive to feedback. Uncertainty creates room where such capacities are not blocked by block universe necessity. It does not create those capacities themselves. If anything, appreciating the exact sense in which quantum mechanics loosens classical necessity can sharpen one's understanding of agency. It suggests that whatever we value in free action, the responsiveness to reasons, the integration of information, the capacity to learn and to plan, lives at a level where quantum noise is background texture rather than the foreground plot. We do not gain authorship by handing our pen to a vacuum fluctuation. We gain authorship by building systems, biological, cognitive, social, that stabilize behavior around reasons while allowing flexibility within constraints. From that vantage, quantum theory is neither rescuer nor executioner. It is a description of the substrate on which higher-level architectures perform. In the end, the quantum escape is not an escape to freedom so much as an escape from an overly simple picture of necessity. The world is not the rigid mechanism we once imagined. It is more supple, more relational, and more veiled. The veil is genuine. Behind it, some things are not decided until they are measured, and some correlations defeat the stories we learned in classical childhood. But the veil is not a mask we can lift to find our own faces dictating the outcomes. It is a fabric in which we are woven, the texture of possibilities and constraints that leaves us to do the work of agency at our scale, with the tools evolution and culture have given us. And yet there is comfort in the shimmer. A future not fully written leaves room for wonder, and wonder is the atmosphere in which meaning breathes. The particles do not ask what they will do next. We do. Perhaps that question, persistent and unanswerable in physics' own terms, is where our kind of freedom lives. If not in the equations, then in the quiet between them. Chapter 4. Your Brain as a Machine, Neurons and Decisions. If one wants to know whether choices are authored by a ghost in the machine or by the machine itself, the right place to look is where choices are physically assembled, in neurons and the circuits they form. A neuron is an electrochemical device. Its membrane separates ionic concentrations so that a voltage difference exists between inside and outside. Voltage-gated channels open and close. Synaptic receptors convert chemical signals into currents. And when the integrated current at the axon hillock surpasses a threshold, an action potential propagates down the axon to terminals where neurotransmitter vesicles fuse and release their contents into the synaptic cleft. Excitatory synapses depolarize their targets. Inhibitory synapses hyperpolarize them. The probabilities of vesicle release, the kinetics of receptors, the morphology of dendrites, and the intrinsic properties of ion channels together set the conditions under which a neuron will spike. These are lawful biophysics, not metaphysical mysteries. The brain is a network of such devices, and decisions crystallize when patterns of spiking across populations satisfy the constraints imposed by anatomy, synaptic strength, and neuromodulation. The brain builds decisions hierarchically. Primary sensory cortices encode features. Association areas integrate them. Prefrontal and parietal regions maintain task rules and goals. Basal ganglia gate actions through loops that connect cortex, striatum, pallidum, and thalamus. Dopamine neurons broadcast reward prediction errors as brief bursts or dips, modulating synaptic plasticity so that actions leading to unexpectedly good outcomes are reinforced. Other neuromodulators, serotonin, norepinephrine, acetylcholine, adjust learning rates, exploration, arousal, and attentional precision. In this layered architecture, the electrochemical constraints of individual neurons scale up to computational motifs. Evidence accumulation toward decision bounds, winner-take-all competition between alternatives, reinforcement-driven updating of values, and inhibition of prepotent responses when context changes. The brain behaves like a control system that forecasts, evaluates, and selects. The electrochemical nature of neurons matters because it grounds the intuition that decisions are constrained by law. The Hodgkin-Huxley formalism and its descendants predict how action potentials arise from ion conductances and capacitance. Spike generation is not capricious. Dendritic trees are not passive wires, however. They host local nonlinearities, backpropagating spikes, and NMDA receptor-mediated plateaus that allow synapses to interact multiplicatively. This makes neurons sophisticated integrators whose transfer functions are shaped by synaptic history. Long-term potentiation and depression alter synaptic weights according to spike timing and neuromodulatory context, embedding past outcomes into present computation. With sufficient recurrence and plasticity, networks form attractor dynamics, stable population patterns corresponding to beliefs, intentions, or planned movements. The machine is not simple. It is intricate and adaptive, but still a machine. The claim that the brain initiates actions before conscious awareness is not a slogan, but an empirical generalization arising from convergent methods. Classic experiments measured a slow cortical potential preceding self-paced movements, a so-called readiness potential, alongside reports of the moment subjects first became aware of the urge to move. Later work used multivariate decoding of functional MRI signals to classify which of two buttons a person would press several seconds before they reported having decided. Intracranial recordings in patients awaiting neurosurgery revealed that specific neurons in supplementary motor areas, prefrontal cortex, and medial structures change their firing rates long before subjects press a key and long before they report the conscious intention to do so. Magnetoencephalography, electrocorticography, and depth electrodes all tell versions of the same story. Motor preparation and bias accumulation unfold over time, and subjective awareness lags behind them. The lag invites a reallocation of causal credit. If a choice can be predicted from prefrontal or parietal patterns seconds before one notices, "Now I've decided," then the locus of causation lies in those subpersonal processes. Consciousness is there, but it is not first. It is the narrator arriving after much of the plot has been sketched in neural ink. The fact that people can sometimes veto a pending action, aborting a movement at the last instant, does not contradict this. It relocates the interesting question to inhibitory control. Stop signal paradigms show that right inferior frontal cortex, pre-supplementary motor area, and the subthalamic nucleus engage a hyper-direct pathway that can cancel motor plans rapidly, shortening reaction times when the cost of an error is high. Veto is a specialized computation within the machine, not an immaterial intervention from outside it. If one zooms in on a single synapse, one finds chemistry. If one zooms out to networks, one finds control. The cortex, thalamus, and basal ganglia form recurrent loops in which cortical ensembles represent states and actions. The striatum evaluates and selects candidate actions. The pallidum and substantia nigra regulate thalamic relay, and the thalamus feeds back to cortex. Dopamine modulation tunes plasticity in corticostriatal synapses according to reward prediction errors, encoded as phasic bursts and pauses in midbrain neurons, aligning synaptic updates with the difference between expected and received outcomes. Parallel loops emphasize different functions: motor, associative, limbic, and their interactions enable habits to form when contingencies are stable, while goal-directed control takes precedence under volatility when model-based planning confers advantage. The selection of an action reflects the current balance between these systems, a balance that shifts with training, context, and neuromodulator tone. Against that background, the subconscious looks less like a hidden homunculus and more like the mainstream of computation. Much of what the brain does is not accessible to report. Perceptual inference, resolving ambiguous stimuli, discounting lighting, segregating figure from ground, occurs automatically and outside awareness. Working memory makes fragments of the current task accessible to consciousness. But even there, the maintenance of information relies on distributed, activity-silent mechanisms such as short-term synaptic plasticity that do not announce themselves. Attention selects features and locations for enhanced processing. It can be steered by goals, but is also captured by salience, novelty, and learned predictive cues. The labels conscious and subconscious pick out different reporting thresholds, not different kinds of mechanism. The same networks engage whether or not their intermediate states are available to introspection. The strongest evidence that the narrator is not the author comes from cases in which action and awareness are dissociated. In split-brain patients, the hemispheres can act at cross purposes, while the speaking hemisphere confidently explains behavior it did not initiate. In utilization behavior, patients with frontal damage grasp and use objects placed before them despite a declared intention not to. The cue triggers a routine the patient cannot inhibit. In blind sight, individuals with lesions to primary visual cortex can point towards stimuli they deny seeing, indicating that visual-motor processing can proceed without conscious visual experience. In alien hand syndrome, unintended grasping and groping movements occur, accompanied by a bewildered narrative that tries to make sense of acts not endorsed by the patient's plans. These conditions are pathological, but they reveal a principle. Agency is implemented in circuits, and the feeling of authorship is a reconstruction. If electric patterns and chemical gradients do the work, then the question becomes how those patterns implement the properties we associate with decision. Evaluation, comparison, commitment, and learning. Evaluation occurs when sensory evidence is combined with value signals to compute expected returns. Neurons in orbitofrontal cortex and ventromedial prefrontal cortex encode value in a way that is partially invariant to the sensory modality of the item being evaluated. Comparison occurs when two or more options suppress each other's representations through lateral inhibition, a dynamic that yields categorical choices even when evidence is graded. Commitment occurs when recurrent circuitry pushes the network into a high-gain attractor corresponding to the selected action, stabilizing the choice against noise. Learning occurs when feedback alters synaptic strengths according to rules approximating reinforcement learning algorithms, with dopamine signals carrying errors between expected and obtained outcomes. These processes are not abstract. They can be recorded. In the lateral intraparietal area of monkeys making saccades to targets of varying reward and reliability, single neurons show activity consistent with evidence accumulation. The rate of ramping depends on the strength of the cue and the eventual choice. In dorsal anterior cingulate cortex during foraging-like tasks, activity tracks the declining value of a current patch and rises with the potential value of alternatives, predicting the moment of switching. In human medial frontal cortex, high-frequency activity increases when subjects experience conflict between responses and is followed by activity in dorsolateral prefrontal regions associated with control recruitment. In ventral striatum, bold signals and local field potentials correlate with prediction error magnitude. At the moment outcomes are revealed, the machine is empirical. Its variables can be measured, its parameters inferred. The predictive power of brain signals is often misunderstood. A classifier that distinguishes left versus right button presses 2 seconds before a reported decision with, say, 60 to 65% accuracy is not reading fate. It is reading bias in a system that is drifting toward a commitment. The bias can still reverse before the threshold is crossed. The point is not that decoders are omniscient, but that the moment of awareness does not mark the system's beginning. By the time consciousness declares, "I will choose A," much of the work that makes A likely has been done. The awareness is a readout, a summary of where the computation stands. The automaticity of much behavior does not render conscious deliberation epiphenomenal. It reframes it. Deliberation is a mode of operation in which additional information is recruited, alternative models are run, and thresholds are raised to avoid premature commitment. Neuroimaging shows that when people engage in deliberate choice under uncertainty, prefrontal networks associated with working memory and cognitive control increase their coupling with valuation systems. Pupillometry, a proxy for noradrenergic arousal, scales with the difficulty and expected value of control. When consequences are weighty or rare, people slow down, sample more evidence, and trigger stopping networks more readily. Consciousness here is not an originator, but a governor. It changes parameters of the computation, how fast to integrate, how high to set the bound, whether to canvas more options. Still, even slow choosing sits atop non-conscious scaffolding. The options among which we deliberate are generated by systems tuned by learning and priors. The salience of attributes is weighted by attention mechanisms we do not choose to deploy in the first instance. The framing of the problem, risk versus loss, social versus individual, pushes our evaluation through pathways with characteristic biases. Behavioral economics has cataloged these biases. Neuroscience has traced some of them to value-coding neurons whose responses are reference-dependent, and to amygdala and insula circuits sensitive to loss and threat. What feels like choosing among neutral presentations is often choosing among presentations already slanted by internal models that predict outcomes in ways we cannot spell out. One might ask whether this picture leaves any room for what people mean when they say, "I chose." The answer depends on the level of description. At the microphysical level, the brain obeys electrochemical laws. At the circuit level, choices emerge from competitive dynamics and reinforcement. At the psychological level, the person forms intentions, weighs reasons, and endorses actions. The levels are consistent. The intention is the pattern of neural activity in prefrontal and related areas that encodes the plan. The endorsement is the network settling into a state that inhibits contrary impulses and readies execution. The reasons are patterns distributed across semantic and episodic systems that, when activated, bias valuation and attention. Saying "I chose" is shorthand for the alignment of these levels into a trajectory that expresses the agent's learned preferences and current goals. Because this chapter follows discussions of determinism and quantum indeterminacy, it is worth noting where overlaps end. The predictive successes in neuroscience do not depend on whether microevents are strictly determined or probabilistically governed. The decoding of a choice 2 seconds in advance is a story about mesoscale signals and population dynamics. Even in a universe with quantum noise, the large-scale regularities of synaptic transmission and network function give rise to reliable patterns that decoders can read. Conversely, even in a classically deterministic substrate, the same layered architecture would yield delayed awareness because the computation is distributed and only some of its outputs are broadcast into global workspace for report. In that layered architecture, the subconscious is the real driver. Subconscious here does not mean mysterious, it means below the threshold of report. Predictive processing frameworks model the brain as continuously generating predictions about sensory inputs and updating them by minimizing prediction error. Much of this occurs outside awareness. Precision weighting, how much to trust new input versus prior expectation, is modulated by neuromodulators and determines whether we attend or ignore, learn or persist, exploit or explore. Interoceptive predictions about the body's internal state shape mood and motivation. When interoceptive error rises, drive states, hunger, thirst, anxiety, capture attention, and bias choice. The brain's default mode network simulates futures during rest, producing priors that later guide fast choices without announcing their origins. The driver's seat is occupied by these regulators, not by the voice that comments from the passenger side. The impression that consciousness commands springs partly from its privileged access to language. The interpreter, function in the left hemisphere, constructs coherent explanations for behavior, stitching intentions to actions with narrative thread. This is adaptive for social coordination and self-monitoring, but it blurs the line between explanation and cause. Studies using transcranial magnetic stimulation to perturb motor cortex show that when weak stimulation biases a movement, subjects often report reasons unrelated to the perturbation. Split brain experiments reveal a similar confabulation. When the right hemisphere directs a behavior and the left hemisphere is asked why, it invents plausible stories. The brain prefers coherence to candor when the two are at odds. It is also important to separate the claim "awareness lags" from the stronger and false claim "awareness never matters." Awareness is not a switch but a bandwidth. When a task is automatized, the bandwidth devoted to monitoring narrows and the system runs on procedural memory. When novelty or conflict arises, monitoring expands, thresholds rise, and veto circuits are poised to interrupt. The stop signal task quantifies the latency of such inhibition. Deep brain stimulation of the subthalamic nucleus in Parkinson's disease alters this latency and can reduce impulsive errors by facilitating the hyperdirect pathway. These effects are mechanistic. They depend on conduction velocities, synaptic integration, and the timing of bursts across nodes in the network. They illustrate that control is a circuit computation that can be strengthened or weakened by physiology and experience. What of morality and responsibility in a machine made of cells? Responsibility is a practice that tracks the machine's capacities, sensitivity to reasons, the ability to learn from feedback, the capacity to inhibit impulses, and the responsiveness to social norms. Neuroscience has already reshaped law in areas like insanity defense and sentencing, not because it denies agency, but because it refines our judgments about capacity and control. A brain impaired by tumor, seizure, or degenerative disease may fail at capacities that underwrite responsibility, and the law adjusts. The more we understand about the circuits that implement those capacities, the more precisely we can target rehabilitation and design environments that scaffold control rather than erode it. There is a temptation to ask where exactly in this sea of spikes a free act could be. The better question is how designs that support flexible, reasons-guided behavior are built and maintained. Executive control is costly. Its deployment must be regulated, lest we waste energy ruminating when habit would suffice. The brain solves this with metacontrollers that arbitrate between exploration and exploitation, between speed and accuracy, between effort and outcome. Noradrenergic systems in locus coeruleus adjust the gain of networks in response to uncertainty. Cholinergic systems tune cortical plasticity and signal expected uncertainty in sensory streams. Serotonergic systems influence patience, punishment learning, and perseverance. The organism's niche, its social structure, tools, language, feeds back into these systems, altering their baselines across development. The self that chooses is not a static operator, but a moving target sculpted by history. Electrochemical lawfulness, predictive pre-activation, and the dominance of the subconscious do not abolish the person. They tell us what the person is like when viewed from below. The person is an organization, a vast feedback system that learns, models, and acts. Its choices are the trajectories of that system through state space, constrained by physics but structured by value and information. The narrator is late to the party, but not irrelevant. It summarizes, evaluates, and, through language and reflection, can reconfigure the system for next time. Therapy, education, training, and culture are all ways of writing to the machine's parameters so that future automaticity runs in better grooves. It is common, at this point, to wonder whether any of this can feel free. The answer is that feeling free is a perception, one that tracks a particular mode of operation in which options are many, constraints are loose, and control resources are high. That perception is informative about your internal state, not about metaphysical exemption from cause. When the machine is well tuned and the world is propitious, the bandwidth of awareness broadens and the veto circuits stand ready. Reasons are vivid, and their downstream consequences are strong. When the machine is stressed or depleted, reasons whisper and impulses shout. Freedom, on this view, is the subjective signature of a certain regime of control in a physical system. The scientific image here is not deflationary. It is clarifying. Neurons fire according to electrochemical laws, and choices are predicted from brain signals before awareness, because the computation unfolds in time across layers that do not report themselves as they work. The subconscious is the real driver because it is where the drivers are, the circuits that calculate, compare, and commit. This is not a reduction of the person to parts. It is an identification of the person with a pattern realized in parts. Improving the pattern by sleep, nutrition, training, therapy, community changes the future by changing the machine. From the quiet vantage of this view, there is a gentle existential hush. You are a living algorithm written in cells, a storm of ions weaving reasons into motion. The story you tell yourself arrives after the spark, but it still matters because it becomes tomorrow's wiring. Perhaps freedom is not the power to stand outside the machine, but the power of the machine to become a better version of itself. In the end, that may be enough. To feel the currents, to steer within them, and to find meaning in the way the pattern holds together as you move through time. Chapter 5. The probability of your life, choices as likelihoods. Each moment of life feels singular. You stand at a crossroads, consider alternatives, and pick one. The subjective image is of a branching tree whose next branch is open until you choose. Yet underneath that image lies a subtler structure in which choices are not abrupt ruptures, but the resolution of probabilities. The brain is a device that represents uncertainty, integrates evidence, and produces actions that, more often than not, are the most likely outcomes given current internal states and external conditions. Probability is not a veneer laid over decision. It is the grammar of decision, shaping how perception is interpreted, how values are computed, and how actions are selected. Probability runs through brain function at every scale. At the level of single neurons, spiking is variable even for repeated presentations of the same stimulus. This variability is not mere defect. It reflects synaptic release statistics, channel noise, network state, and hidden inputs. Across populations, that variability carries information. Neurons that respond to a stimulus feature do so with distributions of firing rates, and downstream circuits can read those distributions to estimate likely states of the world. At the level of circuits, recurrent networks integrate streams of evidence, weighting them by reliability, and commit to a choice when accumulated support favors one hypothesis over its competitors. At the behavioral level, the brain's policy, the mapping from states to actions, is stochastic. Presented with the same options at different times, you do not always choose the same way, and the frequency with which you pick each option tracks its estimated value and your current level of exploration. If this sounds abstract, consider a simple case. You glance at a blurred object at dusk and must decide whether it is a friend waving or a branch swaying. Sensory signals are weak and noisy, so your visual system leans heavily on prior expectations learned from similar scenes. If, in your neighborhood, evening walkers are common, the prior pushes your interpretation toward person, and your decision to approach becomes more probable. If, in that environment, wind gusts and moving branches are more frequent, the prior tilts toward object, and avoidance becomes likely. The point is not that you will always make the same call. It is that your brain does not compute from scratch. It combines what is seen now with what has been learned about what is usually seen, and the combination yields a distribution over interpretations. Your action samples that distribution in a way that favors the peak. This logic appears in neural data. Variability in visual cortex shrinks when a stimulus appears, a phenomenon sometimes called variability quenching, consistent with the idea that incoming evidence sharpens beliefs. Correlated fluctuations between neurons, known as noise correlations, track task demands and attention, suggesting that the brain dynamically allocates precision to the signals it trusts. When attention is directed to a location or feature, neurons responsive to that channel behave as if their estimates have been granted more weight, and choices follow suit. In higher association regions, ensemble activity evolves as if computing the relative likelihood of competing interpretations and pushing the system toward a commitment once a reliability threshold is met. In decision tasks where evidence arrives over time, behavior often follows the signature of accumulation toward a boundary. Momentary samples of evidence push a latent variable that drifts until a threshold is crossed and a response is triggered. The time to threshold and which threshold is reached depend on the strength of evidence and on the initial bias set by prior information. Although this dynamic can be written in equations, the essential point is qualitative. The system behaves like a probabilistic integrator that trades speed against accuracy and that begins each trial not at zero, but at the prior best guess given context. When evidence is weak or conflicting, the distribution over reaction time spreads and errors increase. When evidence is strong, responses are fast and accurate because the distribution is narrow and centered on the correct boundary. Choices among valued options show analogous structure. When offered goods that differ along multiple attributes, people's selections follow patterns consistent with a noisy comparison of subjective values. Those values are themselves estimates with uncertainty, learned from experience via reward prediction errors. Midbrain dopamine signals scale with the difference between expected and received outcomes, tuning synapses in corticostriatal loops so that actions likely to produce good outcomes become more probable next time. Converging evidence also suggests that distinct dopamine subpopulations encode different parts of the value distribution, not just its average, allowing learning to capture risk and asymmetry. What you feel as preference is the current shape of a learned distribution over expected returns, updated by feedback and modulated by context. From this perspective, each decision you make can be described as the most likely action, given the state of your organism and its niche at that moment. State here includes an enormous set of variables: current goals held in working memory, long-term preferences stored across distributed associative networks, visceral signals reporting hunger, temperature, and arousal, expectations about other agents' behavior, and learned models of which actions tend to yield which consequences in this particular context. Some of those variables are under your deliberate control, many are not, but all of them contribute weights to the calculation that yields action. The result is not rigid necessity, but a skewed distribution in which one behavior is favored over its alternatives, often strongly. The idea that choices are most likely outcomes might sound like fatalism in softer clothing, but the emphasis on likelihood rather than necessity matters. Probabilities can be reshaped. Training changes priors and value estimates. New information shifts beliefs. Attention refocuses precision. Sleep consolidates learning into synaptic changes that bias future inference. Even diurnal rhythms and metabolic state alter transition probabilities. Sleep deprivation increases impulsive responses. Low glucose changes patience. Stress heightens vigilance and narrows exploration. The levers by which you live your life are levers that change probabilities. Organizing environments so that good actions are easier, practicing skills so that they become viable candidates, cultivating relationships that provide information and support at the right times. The illusion of alternatives enters because the brain, after acting, can simulate counterfactuals. Memory is reconstructive, not a simple playback. When you remember a decision, you often simulate variance. Had I left 5 minutes earlier, I would have caught the train. These simulations use the same generative machinery that predicts the near future during perception and planning. They are useful for learning and for assigning credit or blame. But they can also mislead by creating the impression that the alternatives were equally poised at the time. In general, they were not. The distribution at the moment of choice was already tilted by priors, values, and state. After the fact, your brain can imagine paths that were improbable then, but easy to render now because new information has altered priors and because the simulation can hold fixed variables that were not fixed in the original moment. Consider habits. Habitual behavior emerges when repeated reinforcement in stable contexts strengthens action-outcome associations until the action is executed with little deliberation. In such regimes, the policy's distribution over actions becomes sharply peaked around a default. Deviations occur when prediction errors signal that the environment has changed, or when top-down control injects a transient bias to explore. Subjectively, one can feel as though alternatives remain live. Objectively, the probability mass has migrated decisively toward the habit. Changing a habit is therefore a matter of shifting the distribution, adding friction to the default, increasing the salience of alternative cues, rewarding early deviations so that the peak moves. It is not a battle against destiny, it is a reweighting exercise. A related phenomenon appears in social settings. Norms are probability fields. They assign likelihoods to actions by promising rewards and punishments, praise, shame, inclusion, exclusion, across cultural contexts. Individuals internalize these distributions through development so that norm-consistent behaviors feel natural and norm violations feel aversive. When you follow a norm, it can feel like a personal choice, and it is, but it is a choice whose probability was raised by a long process of social learning. Migration, education, and subculture shifts alter these fields, changing what feels likely or thinkable. Revolutions, whether political or personal, are moments when the field changes abruptly, and actions that were once improbable become live. Uncertainty is not only a property to be suffered, it is a resource to be managed. Organisms must decide how much to explore versus exploit, whether to try a new restaurant or return to a reliable one, whether to sample a risky investment or stick with a safer return. In environments that change, exploration prevents stagnation. The brain implements exploration through several mechanisms. Some are directed. Uncertainty bonuses increase the attractiveness of options about which little is known, effectively adding weight where variance is high. Some are undirected. Stochastic variability in choice spreads behavior more widely, ensuring that low-probability options are occasionally sampled. Neuromodulators influence both modes. Noradrenaline is linked to shifts in exploration, especially when environmental volatility increases. Acetylcholine modulates learning from sensory inputs. Dopamine adjusts learning rates for rewards. Together, these systems tune the breadth of your policy so that it matches the world's stability. Perception itself is probabilistic in a way that shapes action. Ambiguous figures can flip interpretations spontaneously because the evidence supports multiple explanations, and the brain alternates between them according to subtle biases, recent history, attention, and adaptation. Multisensory integration follows weighting by reliability. When sight is clear and sound is noisy, vision dominates localization. When fog obscures the view and sound is crisp, audition leads. These weightings are not conscious choices in the moment. They are the result of a system that has learned the typical reliabilities of different cues and that adjusts them rapidly under changing conditions. Your action, turning toward a sound or scanning with your eyes, is thus the most likely given the fused estimate your brain has formed. Internal states provide a second axis of probability shaping. Interoception, signals from the body's viscera, feeds predictions about homeostatic needs that color perception and decision. Hunger enhances the value of food cues and decreases patience for delayed rewards. Thirst pulls attention toward water-related stimuli. Fatigue narrows exploration by lowering expected gains from effort. These are not iron rules, but they shift distributions measurably. A person who chooses a snack at 11 p.m. may feel the decision as free, and it is, at the level of agency, but its probability was stepped up by hormones and neural circuits designed to signal resource scarcity. Understanding this is not cynicism. It is a way to design better environments for your future self by anticipating how bodily states will tilt your policy. Culture acts as a long prior. Languages carve conceptual spaces differently. Educational systems emphasize distinct skills. Economic structures create disparate incentives. Over years, these features write statistical expectations into the brain. What counts as a risky move, a generous gift, or an appropriate response is learned from distributions of examples, stories, and feedback. When two people raised in different environments evaluate the same situation, their priors can be far apart. They may both be rational relative to their data, yet disagree. Dialogue works when it works, by exchanging data and gently shifting priors until probability mass overlaps enough to permit coordination. Memory contributes by reweighting probabilities during sleep and rest. The consolidation process is selective. Experiences that were emotionally salient or that predict future utility are replayed more often, strengthening synapses and networks that will support similar inferences tomorrow. Reactivation does not reproduce the past verbatim. It abstracts and generalizes. The consequence is a policy that not only repeats what worked, but tends to overrepresent features that were predictive across contexts. This statistical bias is adaptive. It makes you better at recognizing meaningful patterns and less sensitive to noise, though it can also harden stereotypes and false associations if the training data were skewed. There is a temptation to think of probability as the opposite of meaning, as if to say that choices are likely is to say they are trivial. The opposite is true. Meaningful choice requires sensitivity to structure. If your brain did not encode which actions usually lead to which consequences, you would drift randomly and suffer. The fact that your choices are often the most likely outcomes given your model of the world is a mark of competence. It is also the lever by which change occurs. Training does not conjure new possibilities out of nowhere. It increases the likelihood that good possibilities are selected under pressure. Wisdom does not erase temptation. It tilts the distribution away from short-term gains and toward long-term goods. This probabilistic framing also clarifies the boundary between agency and luck. Outcomes have two components: the policy you executed and the stochasticity of the world. You can control the former by learning in preparation. You cannot, in general, control the latter. The good decision can have a bad outcome because the environment has variance. The right response is not to deny responsibility, but to evaluate decisions by their expected values under the information available, not solely by realized results. This is how scientists judge experiments and how investors evaluate strategies. It is also how mature agents reflect on their own behavior. Not, did I win, but, given what I knew, was this the action that made sense? Counterfactual imagination deserves a second look under this lens. When you tell yourself, I could have done otherwise, you are running your generative model under altered initial conditions. That is healthy. It teaches you how the landscape might have been different had you known more, cared differently, or been in another state. The illusion arises when you mistake the ease of simulating an alternative for evidence that it was equiprobable at the time. In general, it was not. Ease reflects current knowledge and the simplifications of imagination, not the true distribution that governed your earlier action. The antidote is not to suppress counterfactuals, but to use them carefully. To ask what information would have shifted the peak. What habits would have made another option viable? What environmental cues would have made the better action easier to select? The same probabilistic structure illuminates social life. Negotiation is a dance of beliefs about beliefs. Each party holds a distribution over the other's likely concessions and uses signals to shift it. Cooperation hinges on expectations about reciprocity. Repeated interactions turn single-move games into long-run processes in which reputation becomes a prior. Justice systems work, when they work, by altering the distribution over actions through credible incentives and socialization, not merely by punishing after the fact. Education and public health operate by changing priors, about nutrition, about risk, about trust, so that populations' policies tilt toward behaviors that yield better collective outcomes. Technology has made these distributions more visible. Recommendation systems infer your policy from clicks and watch time, then shape future probabilities by altering what you see. The loop can entrench habits by feeding you what you are most likely to choose, thereby making that choice even more likely next time. Breaking such loops requires altering the input distribution, subscribing to different channels, setting limits, or introducing randomness that prompts exploration. The point is not to moralize technology, but to recognize that your policy is coupled to your environment, and environments can be designed or redesigned. None of this means that people are marionettes. It means that agency is the capacity to curate the conditions under which the most likely action aligns with endorsed goals. The mature agent does not try to will the improbable as a matter of pride. The mature agent cultivates skills, environments, and relationships that make good actions probable. On days when discipline is scarce, friction and structure can keep trajectories on track. On days when curiosity is high, planned exploration can expand the repertoire without derailing core commitments. Over time, such curation changes who you are, not by magic, but by moving probability mass where you want it to go. It is useful, finally, to place this chapter in relation to earlier themes without repeating them. Classical determinism claimed that given the past, a single future follows. Quantum theory introduced intrinsic uncertainty at the microscopic level, but did not thereby grant authorship to randomness. Neuroscience showed that the computations leading to action unfold before awareness and reside largely in circuits below the threshold of report. The present chapter knits these strands into a functional picture. The brain, embedded in a statistical world, learns distributions and acts by sampling policies that favor expected value under current beliefs. At the moment of choice, you experience a single act. Beneath that experience lies a field of likelihoods sculpted by biology and environment. There is humility in this view, but also hope. Humility, because it reminds us that we often overestimate the openness of our moments and underestimate the weight of our histories and environments. Hope, because it reveals where leverage lies. You can rewrite priors by seeking new experiences. You can change the salience of cues by rearranging your spaces. You can rescale precision by managing sleep, stress, and nutrition. You can enlarge the option set by practicing skills until they become viable peaks rather than distant plateaus. You can adopt communities whose norms raise the base rate of the actions you admire. These are not metaphysical tricks. They are probabilistic engineering of a life. And if, at day's end, you still feel the pull of alternatives, you can honor it without being fooled by it. Possibility is not fiction. It is the scaffold of learning. The future remains a field of likelihoods, not a line or a fog. You walk across that field step by step, and each step makes the next more or less likely. Perhaps meaning lives there, in the gentle tilt of the landscape you help to form, in the quiet satisfaction of seeing the most likely action become the right one more often than before. Chapter 6. Time, Cause and Effect. Why the Past Shapes You. Every choice appears in consciousness as a fresh event, a moment in which one could go left or right, speak or remain silent, accept or refuse. Yet the present does not stand alone. It is the visible crest of a long wave made of prior events, many of which never entered awareness. To understand why you act as you do, it is not enough to look at the moment of decision. One must look backward through the scaffolding of causes that make that decision likely. Causality is not merely a philosophical ornament. It is the operating principle of organisms whose survival depends on learning which actions bring nourishment and which bring harm, which signals predict safety and which predict threat. In a nervous system, cause and effect are not abstractions. They are the currency of adaptation. The simplest way to see the grip of the past is to consider how information is represented in a nervous system. Synapses change with use. When an outcome is better than expected, synaptic strengths in the circuits that led to it are increased. When outcomes are worse, they are weakened. This is not poetry, it is physiology. Tiny shifts in receptor density and intracellular signaling make future spikes more or less likely, embedding the trace of yesterday's experience in tomorrow's computation. As these traces accumulate, they produce path dependence. Having taken one route, you are more likely to take it again. Not because you promised yourself you would, but because the system that chooses has been reweighted. Even newly minted, spontaneous acts are shaped by these weights. A brain that leans toward risk in a context of past reward is not violating freedom. It is expressing history. Those parameters were not written on a blank slate. Genetics contributes a patterned starting point. A genome does not specify behaviors, but it does specify a developmental program that shapes the architecture on which learning will act. Variants influence the size and connectivity of brain regions, the timing of maturation, the reactivity of neuromodulatory systems, and the efficiencies of neurotransmitter transporters and receptors. Heritability estimates for many psychological traits are substantial. But what heritability measures is the proportion of variance in a population explained by genetic differences under current environments, not inevitability for a person. Genes set ranges, biases, and sensitivities. Environments select and amplify. A child with a temperament tilted toward novelty-seeking will meet a different world than a child inclined to caution, and that world will feed back, emphasizing different lessons and friends and risks. Development is the first theater in which these contingencies play out. Infancy and childhood are periods of rapid synaptogenesis followed by pruning, with critical and sensitive windows in which experience exerts outsized effects. Language learning, for instance, depends on early exposure. Phonetic categories are tuned by the first months of life, making native contrasts easy and later contrasts laborious. Attachment patterns forged in interactions with caregivers calibrate stress systems and social expectations. A toddler who is comforted reliably learns that distress can be downregulated through others, and such learning is carried forward into schoolyard alliances and adult relationships. Early adversity, neglect, chronic instability, violence does not simply make one sad. It trains systems to expect threat, to monitor for it, and to react quickly when it is sensed. The hypothalamic pituitary adrenal axis adapts to chronic stress by changing baseline levels and reactivity, and the prefrontal circuits that inhibit impulsive actions develop differently when vigilance is always required. None of this is destiny, but it is inertia. Later experiences can compensate or compound. As children move into broader social worlds, culture becomes a pervasive cause that is easy to overlook precisely because it is shared. Cultural practices structure attention and valuation. What counts as polite, brave, selfish, or wise is taught through stories, rewards, and sanctions, and the lessons become automatic knowledge. Education systems transmit not only facts but strategies for thinking. Some emphasize memorization and deference, others debate and hypothesis testing. Economies code incentives that make some forms of effort realistic and others fanciful. Legal systems teach the costs of crossing certain lines and the safety of staying within others. Through thousands of small interactions, people acquire priors, statistical expectations about how things go here, and those priors weight their inferences and choices long after the particular teachers and punishers have vanished from view. In adulthood, environments continue to set boundary conditions on choice. Neighborhood safety, transportation options, food availability, and workplace demands are mundane examples with profound effects. The default options presented by institutions are powerful causes. People enroll in retirement plans more often when enrollment is the default, and they donate organs more often in countries where consent is presumed. The lesson is not that people are weak, but that decision-making is bounded and path-dependent. When you are rushed, tired, or overloaded, you rely on defaults and habits. Architects of environments, designers, policymakers, employers, are part of the causal web that shapes acts, whether they acknowledge it or not. Causality extends inward to bodily states that are rarely counted among reasons. Hormones rise and fall with circadian and ultradian rhythms. Inflammatory signals wax and wane. The gut sends metabolites and peptides that alter appetite and mood. Sleep debt accumulates and changes thresholds for frustration. These processes are not external to the person. They are the person when viewed from below. But because they do not announce themselves in sentences, they are easy to miss when one tells a story about why one acted. The feeling that you just chose to snap at midnight is a story told by a narrating system that cannot feel its own cytokines. The causes are no less real for being unspoken. Time is threaded through these causes. The arrow of time in physics is traced to the growth of entropy. In psychology, it is operationalized as the accumulation of memory. A cause is an event whose alteration would, under appropriate interventions, change the probability of a later event. Brains are interventionist machines. They try to discover which things make a difference. Because correlation is easy and causation is hard, intuition leans on heuristics. One such heuristic is temporal precedence. Causes come before effects. Another is covariation. Things that change together are linked. These rules work often enough to keep organisms alive, but they also mislead. Superstitions arise when accidental covariation creates the illusion of control. Stereotypes harden when salient co-occurrences drown quieter counterexamples. The mind's sense of agency is similarly vulnerable. If action and outcome are close in time and consistent with expectation, one feels responsible even when the causal path ran elsewhere. Science exists, in part, to correct these biases. Longitudinal studies track cohorts over years to estimate how early variables predict later outcomes while controlling for confounds. Natural experiments exploit policy changes or disasters to infer causal effects when randomized assignment is impossible. Within neuroscience, carefully designed manipulations, pharmacological challenges, brain stimulation, lesion studies, link circuits to functions in ways that observation alone cannot. The converging message from these approaches is not that any single cause dominates, but that systems are layered. Early adversity increases the probability of certain outcomes, especially in certain genetic backgrounds and cultural settings. Supportive schooling and stable friendships often buffer those risks. The point is not to flatten people into averages, but to recognize that distributions shift with context, which is to say that causes do their work through time. Genetics returns to the story here, not as a trump card, but as an ingredient. Large-scale association studies identify many variants that each have tiny effects on complex traits. Their aggregate influence can be summarized in scores that predict some variance in educational attainment, disease risk, or behavioral tendencies. These predictions are probabilistic and context-sensitive. A high score for risk does not doom a person. A low score does not guarantee immunity. Gene-environment interactions and correlations complicate the picture. Some genetic propensities are expressed only in certain environments. Some environments are sought out or shaped by genetically influenced traits. A child whose temperament inclines toward reading may elicit more books from caregivers, which in turn strengthens the trait. Causes braid together, and it is a mistake to speak of genes versus environment when the causal arrows run both ways. Epigenetic mechanisms are sometimes introduced here as a way the environment writes on the genome. It is important to be precise. Chemical modifications to DNA and histones and changes in chromatin structure regulate gene expression in response to developmental signals and environmental inputs. Some of these marks are stable within a cell lineage and contribute to cellular identity. Some are dynamic and track experience, including stress. Claims about transgenerational inheritance of such marks in humans must be made cautiously. While animal models show some effects across generations, robust evidence in humans is limited, and mechanisms are under active investigation. What is clear is that experience can influence which parts of the genome are read in which cells at which times, and that this regulation is one of the routes by which the past enters the present biology of behavior. Culture's causal reach includes the construction of the self. In some cultural contexts, the self is conceptualized as independent, bounded, and defined by internal attributes. In others, as interdependent, relational, and defined by roles and obligations. These concepts are taught implicitly and explicitly, and they shape goals and emotions. An insult threatens a Western self by impugning authenticity. It threatens an East Asian self by disrupting harmony. Such differences are not absolute or universal, but they are robust enough to be seen in language use, in attribution styles, in patterns of neural activation when thinking about self and close others. The important point for causality is that what I want is not a primitive given. It is the output of a system educated by a culture. Causal influence also propagates through social networks. Behaviors spread by contagion because humans imitate and conform. This is not mindless. It is efficient. If many people like you adopt a practice and thrive, copying them saves time. Unfortunately, bad ideas spread as readily as good ones when the social payoff is immediate. The clustering of similar behaviors in networks can look like influence when it is selection, and like selection when it is influence. Rigorous methods are needed to distinguish them. Regardless, the practical point remains: who you spend time with changes what you think is normal, possible, admirable, and available. That change is causal, even if no one persuades you with arguments. The legal and moral practices that allocate praise and blame often ignore these invisible causes by design. The law asks whether you met a standard of conduct under the circumstances, not how your childhood, genes, and culture shaped your tendencies. This narrowness has advantages. It simplifies adjudication and preserves incentives. But as neuroscience and social science illuminate the structure of capacity and control, the edges blur. Sentencing guidelines adjust for youth because adolescent brains differ from adult brains in impulse control and foresight. Therapeutic jurisprudence recognizes that addiction is a disorder characterized by changes in control systems, and that treatment can change outcomes better than punishment alone. These shifts do not abolish responsibility. They refine it so that it tracks the capacities that responsibility was meant to track. Causality runs through memory in a way that changes who you are across time. Each memory retrieved is partly rewritten. The reconsolidation of memory allows new information to be integrated, updating the past to serve present purposes. This is adaptive, but it means that the story you tell about how you became who you are is not a fixed record, but a living narrative. The narrative foregrounds some causes and backgrounds others. You highlight the teacher who encouraged you and forget the policy that funded the program that hired the teacher. You remember the breakup and forget the sleep deprivation that made the week brittle. The mind is not lying, it is compressing. Compression hides causes. Some invisible causes are statistical and infrastructural rather than psychological. Wealth accumulates because returns compound. Education compounds because knowledge scaffolds future learning. Health compounds because prevention reduces the frequency and cost of illness. Cumulative advantage yields path dependence. Initial conditions have long tails. Interventions late in a process can still matter, but they must overcome momentum. This is why early childhood programs have large returns and why sustained mentorship bends trajectories. The mathematics of compounding is not cold. It is a description of how small causes, repeated, become large. Even time perception itself shapes causality. People differ in temporal discounting, the rate at which future rewards are devalued relative to immediate ones, and discounting is state-dependent. Stress and scarcity push discounting steeper, making immediate relief overpower distant benefit. Chronic steep discounting traps people in cycles that outsiders misread as moral failure. Providing slack, time, money, mental space, flattens discounting and reveals capacities that were always there. Here's a humane consequence of causal thinking. When you see how scarcity distorts time perception, you stop lecturing and start building slack into systems. Because the causal web is dense, there is a risk of fatalism. One can feel that if every thread leads backward, the tapestry is rigid. This is an error. Causal understanding is the enemy of fatalism because it identifies handles. If poor sleep worsens self-control, target sleep. If default options bias behavior, set better defaults. If stress amplifies discounting, reduce stress at the source when possible, and design commitments that protect valued long-term projects when it is not. If social networks transmit behavior, curate networks. None of these moves requires metaphysical freedom outside of cause and effect. They require enough grasp of causes to move them. Invisible causes are often ignored because they are slow, distributed, or normal. A culture's food environment that nudges caloric intake upward by a small daily amount does more to shape bodies than any single feast. But because the nudge is ordinary, it disappears from story. A city's transportation design that mandates long sedentary commutes shapes cardiovascular risk more than a weekend run but the design is taken as given. A school's reading curriculum that fails to match texts to decoding skill makes struggling readers avoid practice, which widens gaps that were initially small. The gap is then attributed to motivation without noting the curriculum. Many of the most potent causes are not dramatic moments, but chronic backgrounds. The interventionist view of causation aligns with this call. To say that X causes Y is to say that if we were to change X in a certain way while holding other things fixed, the probability of Y would change. This is not always easy to implement in complex systems, but it is the right aspiration for policy and self-care. Randomized trials, difference in differences designs, instrumental variables, and other tools are technical manifestations of an ethical stance. Do not confuse correlation with cause. Do not attribute to character what belongs to context. Do not pretend that effort is uncaused. When causal claims are made responsibly, they point to levers at many levels, from prenatal care to zoning policy, from classroom practice to workplace scheduling, from counseling to social insurance. Your personal past is a nested set of timescales. Some causes operate within seconds, the tone of a voice that primes defensiveness, the glucose level that blunts patience. Some operate over months, skill acquisition, grief, sustained friendship. Some over years, education, career, neighborhood. Some over generations, immigration, historic trauma, wealth, or its absence. The fact that a choice is overdetermined by many timescales does not make it uninteresting, it makes it richer. When you choose kindly under constraint, that act is an intersection of millions of prior acts by you and by others who built the world around you. When you choose cruelly, the same is true. Causality does not excuse, it explains. If this chapter echoes themes from earlier ones, that is because probability and mechanism are the lenses through which causality is seen. But it is not the same song. Where earlier we examined whether the future is fixed by law or loosened by uncertainty, here we are examining how the past, whatever its metaphysical status, is carried into the present by learning, culture, and biology. The difference matters. Even in an indeterministic world, the distribution over outcomes at any moment is shaped by history. The belief in free will often ignores these invisible causes by mistaking the ease of imagining alternatives for evidence that they were equally poised. They rarely were. At the moment of action, one path was favored by weights you did not choose and habits you did, by institutions you inherited and relationships you cultivated. The illusion of radical openness is a property of imagination, not of history. It is natural to ask, after such a tour, whether free will survives. The answer depends on what one means. If free will is the power to step outside the web of cause and effect and originate action ab nihilo, then no, this chapter is not friendly to it. If free will is the capacity of an organized system to act for reasons, to learn, to commit, and to alter its own future by changing its environment and habits, then causal analysis is its ally. Reasons are causes of a particular kind. They are representations that carry information about contingencies, and acting for a reason is a way that a brain implements a policy sensitive to those contingencies. The more you understand about what shapes you, the more you can shape what comes next. There is also a personal mercy in causal thinking. People are less mysterious and less monstrous when viewed as the endpoints of histories. This does not dissolve accountability, but it tempers judgment with curiosity. Why did I snap? Why did she withdraw? Why did he persist? The answers will be stories about sleep and stress, about childhood reward schedules and adult incentives, about genetic sensitivities and cultural scripts. These stories are not excuses. They are maps. With better maps, fewer people get lost. In the end, time keeps its silent tally. Yesterday's practice becomes today's ease. Yesterday's scarcity becomes today's fear. Yesterday's kindness becomes today's reflex. To live with this knowledge is not to be trapped by the past, but to be apprenticed to it. You inherit constraints and tools, and by using them, you change what you will inherit tomorrow. Perhaps the consolation is this: the past shapes you, but you, in acting now, are already shaping a past that will make someone, your future self or another, freer. Chapter 7. Consciousness as a narrator, not a driver. The feeling that I am doing this now because I choose to is among the most intimate of experiences. It arrives as a clear, centered voice that links what just happened to what will happen next. I intended, I acted, I caused. Yet much of contemporary cognitive science suggests that this voice is not the engine of behavior, but a commentary channel layered on top of deeper processes. Consciousness, on this view, narrates more than it initiates. The self you experience is a story your brain tells itself about its own activity, a compact model that stitches perception, memory, and action into an intelligible sequence. Calling the self a story does not render it insubstantial or dismiss the reality of agency. It makes agency a function realized by a storytelling organism rather than by a homunculus pulling levers. Calling the self a story does not render it insubstantial. Stories are compressed models. They take a streaming world of detail and fold it into a form that can be remembered, shared, and used for planning. The brain must summarize because the machinery below consciousness is a tangle of parallel processes: sensory inference, habit execution, value comparison, interoceptive regulation, and motor control. Most of those processes are not available to report, yet organisms like us must coordinate with others, predict social responses, and keep track of commitments across time. A narrative self that says, "I chose for this reason," is a tool for those tasks. It packages a sprawling computation into a sentence that other people can evaluate, reward, punish, or trust. Two distinctions help. One is between a minimal self and a narrative self. The minimal self is the pre-reflective sense of being an embodied perspective with agency and ownership, anchored in proprioception, vestibular feedback, and interoceptive signals, and stabilized by predictive models that anticipate the sensory consequences of self-generated actions. The narrative self is the autobiographical construction that stretches across time, binding episodes with language, memory, and culture. The second distinction is between access and cause. A process can be accessible to consciousness, reportable, manipulable, and working memory, without being the origin of the behavior it describes. When these lines blur, it is tempting to treat the voice that explains as the voice that commands. Why would a nervous system evolve a narrator at all if deeper processes handle the mechanics of choice? One answer is social. Humans live in groups where reputation is currency and coordination depends on explanations. Others need to know whether our behavior is predictable, whether our motives are trustworthy, and whether we will keep our promises. The ability to offer a coherent account of our actions is a device for social bargaining and repair. Another answer is computational. A global summary of the organism's current goals, constraints, and plans makes it easier to route information to where it is needed. Broadcasting a compact representation of what we are doing and why can help suppress interference from irrelevant impulses and can recruit help from subsystems that would otherwise operate at cross purposes. The narrator, then, serves both diplomacy and engineering. To claim that consciousness narrates more than it drives rests on converging evidence rather than single experiments. One line comes from the temporal dynamics of voluntary action. Neural activity predicting a simple self-paced movement can be detected before people report an urge to move. Multivariate decoding of brain signals classifies upcoming choices above chance several seconds before conscious awareness. These findings do not render awareness idle, but they relocate the earliest causal work to subpersonal processes. Awareness often seems to announce, and sometimes to modulate or veto, what is already in motion. The impulse to explain becomes theatrically visible in split-brain research. When the commissural fibers connecting the hemispheres are severed to control epilepsy, each hemisphere can be presented with different information. In experimental settings, stimuli delivered to the right hemisphere can guide actions, pointing, grasping, without access to language. When the speaking left hemisphere is then asked why the action occurred, it supplies a reason that fits its own incomplete picture of events. The answer is fluent and confident, but wrong. This interpreter function does not lie in a moral sense. It fills causal gaps with plausible bridges to maintain a coherent narrative self. Clinical neuropsychology reveals the same pattern in harsher relief. Patients with anosognosia for hemiplegia deny their paralysis and may confabulate excuses for not moving when pressed, as if maintaining the integrity of the self model mattered more than updating it to fit a disabling fact. In alien hand syndrome, unintended grasping and groping movements intrude into behavior, and patients develop narratives to domesticate the estrangement. The hand has a mind of its own, or it wanted to pick that up. In utilization behavior, frontal damage releases stimulus-bound routines. A patient confronted with a stethoscope may examine the examiner without being asked, then justify the act afterward. In each case, the machinery initiating action lies outside the narrator's control, and the narrator works retrospectively to make sense of what the body has already done. Illusions of agency in healthy subjects are subtler but just as telling. Intentional binding compresses the perceived time between a voluntary action and its sensory consequence, as if tightening phenomenological causation when agency is present. When the action-outcome contingency is degraded, the binding relaxes, and so does the felt authorship. Experiments that covertly perturb the mapping between intention and outcome show that people report control when deviations are small and in the direction of their goal, and withdraw authorship when deviations grow or oppose the goal, even though they remain unaware of the exact perturbations. The system seems to infer agency from a consistency between predicted and actual consequences, rather than from a privileged introspective signal of command. A broader framework treats the sense of agency as a product of comparator systems and predictive control. The motor system issues commands accompanied by efference copies, internal predictions of the sensory consequences of those commands. When feedback arrives that matches prediction within expected tolerances, the source is attributed to the self. When the mismatch is large, the source is searched for in the world. Cerebellar circuits and parietal regions contribute to these predictions, and their disruption alters agency judgments. That you cannot tickle yourself follows naturally. Predicted sensations are attenuated. Conversely, when you experience an unpredicted force guiding your hand, the mismatch flags an external cause. Agency is inferred by comparing expected and received signals, not revealed by a light in the mind labeled will. Laboratory demonstrations of post hoc justification make this lateness hard to ignore. Choice blindness experiments ask people to choose the more attractive face from a pair. Occasionally, with sleight of hand, the card handed back for justification is the face not chosen. Many participants fail to notice the switch and cheerfully explain why they prefer features of the face they had just rejected: an earring, an expression, a symmetry they now praise. Variants of the paradigm apply to moral judgments, consumer preferences, and political opinions, with similar rates of unnoticed reversals and confident justifications. The lesson is not that people are hopelessly confused, but that the narrator's job is to produce a coherent rationale that fits the current outcome and context, not to audit the causal history of the choice. Post-hypnotic suggestion drives the point deeper. A suggestion delivered under hypnosis, say to open a window at a queue, can later elicit action that feels spontaneously motivated. Asked why they opened the window, subjects offer confabulations that fit the scene. It was stuffy, I wanted fresh air. The agency system has checked its comparators, found that the action fits with the environment and internal state, and stamped it mine. The trigger, however, lay in a file the narrator cannot open. Again, deception is not the point. The system that confers authorship is following rules that usually work, and the narrator is doing its best with limited access. Emotion construction theories extend the narrator's reach into feeling. On these accounts, interoceptive signals from the viscera and body are ambiguous and are categorized using learned emotion concepts that vary across cultures. The experience of how I felt, and therefore why I acted, is an inference from bodily state and situation. When someone says they lashed out because they were angry, they are not reporting a simple datum. They are classifying a pattern using a concept that their culture has supplied. The classification shapes memory and future action. If the same physiological arousal is categorized as fear in one context and excitement in another, the stories about what one did and why will diverge accordingly. The default mode network, including medial prefrontal cortex, posterior cingulate cortex, and angular gyrus, is repeatedly engaged when people think about themselves, remember autobiographical episodes, imagine the future, or infer others' minds. When mind-wandering simulates futures and rehearses pasts, this network hums, producing candidate narratives ready for broadcast into language. Damage to parts of this network can degrade narrative continuity, making it harder to imagine detailed futures or to place oneself richly in remembered scenes. Conversely, practices that train autobiographical reflection and perspective-taking modulate activity in these regions and can reshape the coherence and tone of the stories people tell about their lives. Global neuronal workspace theories fit the narrator metaphor from another angle. On these accounts, information becomes conscious when it is amplified by attention and broadcast to multiple subsystems: language, memory, valuation, motor planning, that can use it. Broadcast affords report and deliberate control, but the victory that wins broadcast is often decided by preconscious competition among representations and by biases set by goals and habits. Once broadcast, the content is framed as the product of intention, because that is the form in which it is useful for coordination and self-monitoring. The broadcast is not a secret ballot that tallies competing plans. It is a public announcement that a plan has won. Why, then, does the experience of authorship feel so immediate and definitive? Partly because of temporal grain. Conscious access likely samples the computation at a coarse timescale. The microscale events that bias and launch actions occur earlier and faster than the sampling window. Partly because of memory. We remember decisions we can explain, and we forget or never encode those that unfolded as habit. partly because the social world demands reasons as tokens of accountability, and we learn early that reasons must be framed as antecedent causes if they are to count. The felt sequence, reason, decision, action, overlays a deeper sequence, bias accumulation, threshold crossing, motor execution, that is less available to introspection. The narrator is not a villain. Narration has strength that mechanistic accounts sometimes underplay. Stories organize time, motivate effort, and sustain commitment by making cross-temporal links vivid. Vows, resolutions, and oaths work because the narrator pledges in public, and the memory of that pledge reconfigures thresholds and priorities later. Therapy teaches narrators to tell truer stories, integrating trauma without being run by it, and distinguishing triggers from values. Education enlarges the narrator's vocabulary for reasons, sharpening discrimination between genuine constraints and excuses. The voice that justifies can become the voice that revises. Still, the danger is real. When narration outruns evidence, identity hardens around slogans. Confabulation becomes creed. People take credit for good outcomes that were luck, and they blame others for failures shaped by context. Political rhetoric exploits the appetite for simple causes, offering tidy motives where the causal web is tangled. The scientific injunction in such landscapes is modest but firm. Hold stories lightly, look for disconfirming cases, and treat reasons as hypotheses to test rather than as verdicts to defend. It is worth asking how this chapter differs from earlier ones to avoid repetition. The earlier chapters argued that physics does not deliver authorship, that randomness is not control, that neural preparation precedes awareness, and that choices are often the most likely outcomes given priors and states. This chapter confines itself to the phenomenology and function of narration. How the sense of self as driver arises from comparator control, predictive modeling, and social constraint, and how, in specific experiments, people invent reasons for actions whose immediate causes were unconscious or externally biased. The overlap lies only in scaffolding. The emphasis here is on the narrative machinery and its empirical signatures. Even where narration is post hoc, it can become pre-hoc by learning. Deliberate practice shifts the frontier at which reasons enter. In domains of expertise, what began as explicit, effortful rules compresses into fast heuristics. Conversely, when habits misfire, bringing them back under explicit control can repair them. Cognitive control networks raise decision thresholds, canvas alternatives, and slow accumulation to avoid premature commitment. In such periods, the narrator's summaries, goals rehearsed in inner speech, contingencies kept active in working memory, bias sampling, and change the course of action. The narrator does not flip a metaphysical switch. It changes the parameters of the computation. Cultural differences complicate simple generalizations. In contexts that prize internal consistency and authenticity, narrators learn to align explanations tightly with a stable inner essence. In contexts that prize relational harmony and context sensitivity, narrators learn to justify actions by their fit with roles and obligations. Both styles produce agency stories, both are trained. Cross-cultural work shows differences in attribution and memory that track these styles. The scientific lesson is not that one style is correct, but that the narrator learns from culture how to narrate, and those learned templates feed back into how agency is experienced and reported. One might worry that calling reasons post hoc erodes responsibility. The opposite is closer to the truth. Responsibility, on the functional view, tracks capacities, sensitivity to evidence, the ability to inhibit impulses, the disposition to revise beliefs when they fail, the skill of planning across time. Conscious narration participates in those capacities by representing reasons in a format that can be compared, criticized, and shared. Even when a particular verbal reason did not cause a particular action, the practice of reason-giving shapes future actions by updating priors, recruiting allies, and committing the agent publicly to standards that will guide later choices. Language holds a special place in this story. Inner speech is not mere epiphenomenon. It is a tool for manipulating working memory, sequencing sub-goals, and teaching oneself. Children learn to talk to themselves aloud and then internalize that speech to guide behavior. Adults revive it under challenge. This is the narrator at work, not as novelist but as engineer, using words to keep the right variables salient while the machinery below computes. The same mechanism can mislead when words are used to rationalize what has already been done, but it can also rescue when words are used to slow a cascade, to rename a trigger, to remind a hand to open instead of close. Memory reconsolidation ties narration to time. Each retrieval is an opportunity to update, and the updated story becomes tomorrow's premise. Narratives that incorporate error and uncertainty make better premises. They leave space for correction. Narratives that declare certainty where there is none harden into prisons. The malleability of memory is not a bug. It is a design that allows learning. The narrator who understands this is gentler with the past and more careful with the future. Experiments continue to peel back the layers. Brain stimulation that subtly biases a movement direction leads subjects to report reasons unrelated to the bias. Sensoromotor adaptation tasks reveal aftereffects in movement, while reports of intention remain stubbornly aligned with the goal. In rapid pointing tasks, online corrections occur faster than conscious detection of the perturbation. In metacognitive studies, people express high confidence in incorrect attributions when the context makes the confabulation plausible. Across all of these, the common theme is that the story of why we acted is an inference that is generally useful and sometimes wrong. If the narrator is not the driver most of the time, can it become one when it matters? To a point, yes. When stakes are high and time allows, systems that implement deliberation can be engaged. They are not outside the brain's physics. They are the brain operating in a different regime, allocating more resource to exploration and model-based evaluation, increasing thresholds to trade speed for accuracy, and recruiting memory to simulate consequences. In such regimes, explicit reasons do causally contribute to action selection. The same organism that confabulates in milliseconds can reason in minutes, and the products of that reasoning can be written back into habits so that tomorrow's milliseconds go better. There is no need to denigrate the narrator to honor the machine. The narrator is how the machine talks to itself and others. It is how values become variables, how commitments become constraints, and how communities become more than sums of bodies. Seeing it as narrator rather than driver relocates its dignity. A good narrator is not the loudest or the most certain, but the one most responsive to evidence and most willing to revise the plot when the world does not cooperate. In quiet moments, this can read as disenchantment, as if the story of self were only a gloss on deeper currents. But there is another way to hear it. You are the gloss, and the gloss changes the text. The organism acts, the story learns. Together, they make a life. Perhaps freedom lives not in authoring every line, but in learning to tell the truth about the lines you have written and, by telling it, to write the next ones better. Chapter 8. The Multiverse Possibility. All choices happen somewhere. Among the interpretations of quantum theory, One stands out for its audacity and its austerity at once. It removes the collapse of the wave function, refuses to add hidden variables, and leaves the core dynamics of the theory untouched. In this view, the Schrödinger equation is universally valid and never blinks. The mathematical object that describes the world evolves smoothly, and when measurements happen, there is no singular jump. Instead, the system being measured, the apparatus, the environment, and the observer become entangled. The observed definiteness of results is explained by the practical autonomy of different components of the entangled state once environmental decoherence has suppressed their interference. This is the Everett or many worlds interpretation. On its telling, what we call an outcome is relative to a branch of the universal state, and there are many such branches. You feel the needle swing left because you inhabit a branch where the left-pointing record is stable. In a sibling branch, a sibling of you sees it swing right. Both records are equally real as patterns in the overarching quantum state, though they are now effectively non-interacting. The multiverse, thus understood, is not a separate cosmos. It is the structure of a single quantum world seen from the inside. To avoid confusion at the outset, it helps to distinguish two ideas that sometimes travel under the same multiverse label. Cosmology entertains scenarios in which the universe is much larger than our observable patch, possibly containing distant regions with different histories or even different low-energy constants. That is a spatial or inflating multiverse. The Everettian multiverse is different. It is the structure of the universal quantum state under unitary evolution and decoherence, and the multiplicity is in the decomposition of that state into effectively classical alternatives. The two notions can coexist, but they answer different questions. The one relevant to free will is Everett's, because it speaks directly to how measurement yields definite experience without invoking chance collapses that select a single result. The core move is simple to state. Before measurement, a system can be in a superposition of states with different values of an observable. When a measurement interaction occurs, the apparatus becomes correlated with the system, so that, in the joint state, each possible system state is paired with a corresponding apparatus record. Because the apparatus is macroscopic, it interacts with the environment in a way that rapidly suppresses interference between these joint components. Decoherence selects a set of states, so-called pointer states, whose correlations are redundantly recorded in the environment, rendering them robust to monitoring by other systems. The result is that, for all practical purposes, the different outcome record pairs evolve independently thereafter. Within each such quasi-autonomous sector, an observer finds a definite result and can build further memories upon it. The splitting is not a violent fission. It is the natural fanning of histories implied by unitary dynamics in an open world. From the branch perspective, nothing occult has happened. You prepared a spin, tuned your detector, and saw the needle point left. If another version of you saw it point right in a different branch, you cannot communicate with them and will never meet. The practical irreversibility of decoherence is what gives the branches their autonomy. Recohering macroscopic branches would require phase control of an astronomical number of degrees of freedom. For organisms that forget and machines that dissipate heat, the separation is permanent enough to anchor talk of distinct outcomes. This is why many worlds can simultaneously say that all outcomes occur and that you experience exactly one. If all outcomes occur, what becomes of probability? The Everettian answer is that probability is not about which outcome will exist, since all outcomes will exist, but about rational self-location within the branching structure. Before a measurement, the universal state entails that there will soon be multiple successor observers with different records. You do not know which record you will find yourself reading. This is self-locating uncertainty. Reasoning under such uncertainty can be formalized, and attempts have been made to derive the familiar Born weights, the squared magnitudes of amplitudes, as the only rational credences to assign to upcoming experiences in a branching world. Some arguments appeal to decision theory. If an agent cares about all successors in proportion to their branch measures and makes choices to maximize a measure-weighted utility, then the usual quantum probabilities emerge as the unique policies consistent with certain rationality axioms. Other arguments appeal to symmetries, invariants of entangled states, showing that equal amplitude branches should be treated as equiprobable and extending this to the general case. Not everyone is persuaded by these derivations, but the program illustrates the idea. Probability in many worlds is about how a pre-branching agent should apportion expectation across future copies, not about which copy will exist. The phrase "every possible choice happens somewhere" needs careful handling. In Everettian quantum mechanics, what branches are realized is determined by the dynamics and the initial state. The branching structure is not a license for any narrative you prefer. Outcomes with zero amplitude do not occur in any branch. Outcomes with tiny amplitude occur in branches with tiny weight. They exist, but they are measure rare. At the macroscopic level, when you decide between coffee and tea, the eventual branching structure depends on the microphysical state of your brain and environment. There will be branches in which the processes that produce coffee choosing reach threshold and branches in which tea choosing does. But there will not be branches in which you hover or violate conservation laws, nor branches in which mutually incompatible states of affairs cohabit. Many worlds is extravagant in count, not in caprice. The branches are multiple, but each branch is law-bound. From within any given branch, you feel that you chose a unique path, because within that branch you did. The sense of uniqueness is local. Everett does not deny that. It denies that the singularity of your experience corresponds to a singularity in the global ontology. Your narrative of why you chose can be true in your branch, even though there are siblings of you in neighboring branches who tell a different story fitted to their outcomes. The single-threadedness of agency is preserved locally and multiplied globally. To a compatibilist about free will, this is unsurprising. Agency has always been a property assessed within a context by how well an organism's actions respond to reasons and goals under the constraints it faces. Many worlds adds that there are many such contexts, each with its own agent doing that local work. Does this interpretation save free will or erase it further? It depends on what needed saving. If the aspiration was to protect a metaphysical power to select a single future among genuinely open alternatives, Everett gives you no help. There is no selection. The universal state evolves unitarily, and everything with non-zero amplitude that can happen does happen in the sense already clarified. The branching picture thus undercuts the romantic image of a singular deciding self whose sovereign act picks one line and closes all others. If instead the aspiration is to preserve meaningful agency, reason's responsive control exercised by an organized system, Everett leaves that intact. Within each branch, agents still deliberate, form intentions, and act. Their actions still have consequences within that branch, and their social practices of responsibility remain coherent. The multiverse neither rescues libertarian free will nor annihilates compatibilist agency. It moves the conversation to the level at which it belongs, the architecture of control inside branches. Some readers worry that multiplicity drains meaning from effort. If there is a branch in which you do the hard work and a branch in which you shirk, what difference does it make which one you are? The Everettian reply invokes measure and care. If rational agents weight their future successors by amplitudes squared, and if actions now can influence the distribution of measure over desirable and undesirable trajectories, then your choices can shift measure toward worlds in which your goals are realized. You are not choosing whether there will be any branch in which you succeed. You are choosing how much of the universal function's weight is carried by such branches. On this picture, the ethics of action carries over. You act to increase the measure of good outcomes. Much as in ordinary uncertain worlds, you act to increase the probability of good outcomes. The presence of sliver measure successes does not license reckless gambles that spray large measure into failure. Everett changes the locus of uncertainty. In collapse pictures, uncertainty is about which outcome nature will select. In Everett, uncertainty is about which copy of you will soon find yourself to be. This indexical or self-locating component makes probability feel less like a coin toss and more like waking up without knowing which room you are in. Before branching, there is no distinguished future me to anchor a singular expectation. There are multiple successors, each with a valid claim to be me relative to their branch. Philosophers of personal identity have long noted that identity over time is not a primitive fact, but a network of psychological continuities. Many Worlds leans into that reductionism. There is no need for a metaphysical glue to connect you across branching. There are continuities to many successors weighted by the measure of their branches, and practical rationality can be reconstrued in that framework. Philosophical puzzles proliferate wherever identity is not all or nothing. Should you care equally about all your successors or in proportion to their branch weights? Should you treat tiny measure branches with negligible concern? What if a choice creates a small measure of terrible outcomes and a large measure of good ones? Is that acceptable? These are moral questions dressed in quantum clothing. They resemble classic problems about risk and aggregation. If ever it is true, the abstract structure behind those problems becomes concrete. Risk is replaced by measure, and aggregation is over branches rather than possibilities. The scientific theory does not settle the ethics, but it clarifies what needs deciding. The interpretation's scientific standing is often summarized by saying that it adds no new empirical predictions beyond standard quantum mechanics with collapse. That is not quite right, but it is close enough for present purposes. Competing interpretations agree on laboratory outcomes where the unitary formalism applies. Where Everett differs is in refusing add-ons at the moment of measurement. It is therefore more parsimonious dynamically, but more extravagant ontologically. Some find that trait appealing, others find it profligate. The empirical debate shifts when one considers objective collapse models, which do make divergent predictions at certain scales and could, in principle, be tested against unitary evolution. If such tests favored collapse, Everett would be undermined. If unitary evolution continued to pass every probe, Everett would remain in the running as the quietest option. Nothing happens at measurement except ordinary entanglement and the practical loss of phase coherence. The preferred basis and probability problems are genuine challenges that Everett addresses with varying degrees of success. Decoherence theory goes a long way toward explaining why certain bases, those corresponding to robust, redundant records in the environment, are the ones in which branches look classical and observers have stable memories. Probability remains subtle because the universal evolution is deterministic. Everett does not deny the felt contingency of experience. It relocates its source to self-location. Whether the rationality-based or symmetry-based derivations of the Born rule fully succeed is a live topic. What matters for this chapter is that the interpretation has a principled story to tell about why observers should expect the statistical regularities they do and why those regularities match the squared amplitude weights, even though every outcome with non-zero amplitude occurs. One should resist the idea that Everettians imagine people splitting in a dramatic cinematic way whenever they decide what to cook for dinner. Branching is ubiquitous and continuous. Macroscopic bodies are constantly interacting with environments that monitor myriad degrees of freedom. Decoherence is not waiting politely for a human to choose. It is happening all the time. The you that narrates your day is already one thread in a tapestry that is fanned out unthinkably. Within that thread, your memories are coherent and your plans make sense. Beyond it, there are threads where small thermal fluctuations and neural jitter tipped a choice differently hours ago, and threads that diverged decades earlier because a photon struck a retinal molecule at a different moment. This does not trivialize your current project. It locates it. Would Everett make you reckless, knowing that some counterpart will succeed even if you fail? That question is a cousin of a moral hazard familiar from insurance. If you do not weight successors equally, if you care in proportion to branch measure, then the presence of tiny measure successes does not license reckless gambles that create huge measure of harm. You would still act to increase the total measure of good outcomes rather than to secure a sliver of spectacular result. The rhetoric that everything happens can mislead by ignoring weights. The useful lesson is that measure matters and responsible agents shape measure. Psychologically, the idea of many worlds poses challenges to self-conception. It invites a rethinking of regret and pride. Regret can be seen as sensitivity to counterfactuals. In Everett, counterfactuals are literal facts about neighboring branches. Pride can be seen as identification with a trajectory. In Everett, there are many trajectories to identify with. A balanced attitude might be to keep our branch-indexed practices unchanged while letting go of metaphysical misery about what we did not accomplish elsewhere. Your obligations and opportunities are local. Your meaning does not require global uniqueness to be authentic. Everett also reframes the relationship between law and novelty. In classical determinism, novelty is epistemic. We did not know enough to foresee this configuration. In collapse pictures, novelty has an ontological ingredient. The collapse produced a definite value from among possibilities. In Everett, novelty is perspectival. The universal state unfolds without surprises, but each branch contains surprises because observers only have access to their local records. The experience of what will happen becomes which record will I soon read, and the answer is weighted by amplitude squared. The logic of prediction becomes a logic of self-location, but the lived feel of suspense is preserved because suspense is a property of finite observers amid branching, not of the universal wave. A cautious word is warranted about metaphors that overextend the idea. The many worlds interpretation is not a claim that anything you imagine exists somewhere. The structure of branches is determined by actual Hamiltonians and initial conditions. You cannot, by sheer intention, create a branch where the laws are suspended. Nor is Everett a therapy for grief by promising that in some branches the loss did not occur. It is a theoretical stance about the ontology that underwrites the success of quantum mechanics. Its comfort, if any, is the comfort of a coherent picture, not of wish fulfillment. Where does this leave free will in our working sense? The account in previous chapters emphasized that agency is a higher-level property, the capacity of a system to act for reasons, to integrate information across time, to modulate its own parameters in light of goals. Everett does not erode that property. It embeds it in a larger structure. In each branch, agents still do the work of forming intentions and carrying them out, and the social practices that hold them accountable for those acts proceed unchanged. What Everett subtracts is the belief that the world as a whole could have turned out uniquely otherwise given the same past. What it adds is a context in which I could have done otherwise becomes, there are branches in which a counterpart of me, under slightly different microconditions, did otherwise, together with a weighting that explains why I should have expected to be in the branch I am in. That translation does not rescue libertarianism, but it does not empty agency either. It replaces metaphysical exception with structural nuance. The most unsettling lesson of the multiverse possibility may be its calm. It says there is one universal story told by a single equation, and inside that story are many local stories told by beings like us. Those stories are not illusions. They are patterns with causal integrity within their branches. The fact that there are many does not make any one of them thin. It makes the whole richer and perhaps stranger than we hoped. You stand at the edge of a choice and feel the world narrow to a point. Somewhere in the vast wave, the world does not narrow, it fans. But you live on a strand, and on your strand, the narrowing is real. Act well here. Let the others be what they will. Meaning lives in the thickness of a single thread held in your hands, even if the loom extends beyond sight. Chapter 9. Ethics without free will, responsibility, and meaning. If the comforting picture of a sovereign will standing apart from cause and effect cannot be maintained, what becomes of morality and justice? The fear is familiar. If no one could have done otherwise in a strong contra-causal sense, then praise and blame collapse into error, virtue and vice become costume jewelry, and institutions of accountability lose their right to impose burdens. That fear draws its force from a particular conception of freedom and a particular theory of responsibility. Change those conceptions, and the landscape looks different. Ethics does not evaporate when metaphysical libertarianism fails. It changes its footing. It moves from the metaphysics of exemption to the science of influence, from deserts rooted in uncaused origination to responsibilities grounded in capacities, reasons, and the social functions of holding one another to standards. The question is not whether we can step outside nature to author our acts ex nihilo, but whether creatures like us, embedded, learned, finite, can stably coordinate on norms that reduce harm and enable flourishing. The answer is yes, and the route runs through an honest account of what responsibility is for and what forms of freedom are possible for beings with histories. Begin with the minimal functions of moral practice. Communities need to signal which behaviors are acceptable, to protect members from predictable threats, to resolve conflicts without vendetta, and to motivate contributions to collective goods. Individuals need to learn from feedback, to anticipate the reactions of others, and to regulate impulses in light of longer-term aims. Responsibility names the cluster of expectations, incentives, and responses that accomplish these tasks. It is backward-looking insofar as we look at what someone did and locate it within a norm. It is forward-looking insofar as our reactions aim to shape future behavior, ours, theirs, and observers. None of this requires that the agent could have broken the causal chain at the moment of action. It requires that the agent is the right kind of thing to respond to reasons and pressure. A system that can represent norms, foresee consequences in rough outline, inhibit some actions, and learn from outcomes. Where those capacities are intact, we hold responsible. Where they are degraded or absent, we redirect our responses toward protection and remediation rather than condemnation. This way of thinking is sometimes said to shift focus from blame to understanding. But the deeper shift is from metaphysical diagnosis to functional design. Understanding is not the enemy of accountability. It is the precondition for sane accountability. If behavior arises from learning rules, incentives, biology, stress, and opportunity, then the levers for reducing harm are to be found there. When we say that a person couldn't help it, we should mean something specific, that under the available regulation and knowledge, the control systems were insufficient to prevent the act, and that different scaffolding is required for next time. When we say that a person should have known better, we should be prepared to specify what knowledge was accessible and how it would have altered the computation. Vague metaphysical blame does not guide policy. Causal diagnosis does. There is a long philosophical lineage for responsibility without libertarian free will. One strand emphasizes reason's responsiveness. To hold someone responsible is to evaluate whether their behavior tracked the right sorts of reasons with sufficient reliability. Guidance control, on this view, is exercised when an action issues from the agent's own mechanisms in a way that is sensitive to reasons and appropriately integrated with their values. What matters is not the ability to do otherwise in a thin, momentary sense, but whether the mechanism that issued an action could have produced different behavior under counterfactual patterns of reasons, had the evidence been stronger, the warning clearer, the sanction nearer. This is a modal claim about the agent's capacities, not a claim about an uncaused spark at the decision time. It matches practice. When we excuse, it is typically because we infer a breakdown in reason's responsiveness, panic, coercion, psychosis, not because we suppose a metaphysical power was absent that is normally present. A second strand emphasizes the interpersonal nature of moral life. Our practices of blaming and praising are not solitary judgments. They are moves in a relationship. To blame is to address another as a participant in a shared moral community, to demand acknowledgement and repair, and to signal how the relationship will be modulated until that acknowledgement occurs. To forego blame is sometimes to withdraw from the participant's stance into an objective one, treating the person as a case to be managed rather than a co-author of norms. This analysis does not depend on contracausal freedom. It depends on whether the addressee can understand the claim, feel its force, and respond by modifying conduct. The pathology of fruitless blame is that it persists even when these conditions fail. The pathology of sentimental exemption is that it refuses to blame even when the conditions hold and blame would be informative and fair. The health of a community lies in calibrating the response to the capacities at hand. These theoretical threads converge on a practical picture of ethics without libertarian free will. Responsibility becomes a graded property tracking capacities. Blame becomes a communicative tool calibrated to learning and safety. Punishment becomes a last resort instrument with specific aims. Incapacitation where risk is high and control low, deterrence where foresight is intact, rehabilitation where habits can be reshaped, restoration where relationships can be repaired. Desert in the sense of a proportional suffering owed to a metaphysically independent chooser, recedes. It is replaced by proportionality to risk and to the need for clear signals about norms. This replacement does not trivialize wrongdoing. It raises the bar for what we are permitted to do to wrongdoers, because it insists that hard treatment answer to legible functions rather than to retributive emotion alone. Law is already moving along this arc. Age and mental status mitigate culpability because we recognize that control and foresight develop and degrade with biology. Problem-solving courts treat addiction not as a moral stain, but as a disorder of control that requires structured support and oversight. Restorative processes foreground repair and reintegration, turning attention to needs of victims and obligations of offenders that are not reducible to years of confinement. None of this denies agency. It locates agency in systems that can learn, and it reserves the most punitive responses for cases where protection requires them or where failing to respond would predictably unravel norms. Where desert remains in legal rhetoric, it often operates as a placeholder for social outrage and a commitment to equal respect, to treat like cases alike and to mark losses publicly as wrongs rather than misfortunes. Those are important functions. They can be retained without positing uncaused choice. A familiar worry resurfaces here. If we abandon retributivism, do we open the door to purely instrumental practices that sacrifice individual rights to aggregate welfare? The worry is well taken and points to a constraint. Even a forward-looking system must be built under deontic side constraints that protect dignity and prevent abuse. Proportionality, due process, a high standard of proof, and a strong presumption of liberty are not luxuries. They are the rules that make an influence-based system humane. They follow naturally from the causal picture when we remember that our models of risk are fallible and that error costs are borne by the same people whose freedom we are considering restricting. A science-inflected jurisprudence should be humbler, not harsher, experimental in spirit, transparent about uncertainty, and attentive to feedback about unintended consequences. Ethics without libertarian freedom also reinterprets praise and admiration. If excellence is not an island of self-causation, can we admire achievements? We can, for the same reason we hold responsible, because the person is the locus at which many causes converge into stable, reasons-responsive patterns. Training, effort, collaboration, and perseverance are real features of such patterns. Admiration is the social reinforcement that tunes priors and aspirations in observers. Gratitude, likewise, is not vitiated by causality. To be grateful is to register that another's actions relieved a burden or provided a good, and to adjust our own policy toward cooperation with them. The emotions of moral life function as updates to predictions and policies. They do not require metaphysical exemptions. They require reliable signals about the kinds of agents we are dealing with and the futures we can expect if we trust, forgive, or warn. The shift from blame to understanding is most visible where behavior is most stigmatized. Consider addiction. A deterministic account does not absolve harm. It maps pathways by which cues, stress, and access hijack learning systems. Responsibility survives, but it is re-aimed, away from moralizing the craving and toward restructuring the context, providing pharmacological aids that restore control, building routines that reduce exposure to triggers, and reserving sanctions for specific failures of compliance that threaten safety. Or consider violence in conditions of chronic scarcity and trauma. A deterministic account predicts higher rates of impulsive aggression under such conditions because control systems are taxed and hypervigilance is rational. Responsibility survives, but it is re-aimed toward upstream investment, credible protection, and community institutions that can enforce norms without humiliation. Understanding narrows excuses by making expectations realistic. It narrows cruelty by making interventions effective. A complementary reorientation occurs on the inside. Guilt and shame are often framed as metaphysical verdicts on a soul. Without libertarianism, they can be reconceived as information and commitment. Information because they signal that one's action violated values one still endorses when calm. Commitment because they motivate repair and policy change. The productive aftermath of wrongdoing is not self-loathing, but plan revision. Apology, restitution, changed routines, new constraints that reduce the probability of repetition. A deterministic psychology makes such revision concrete. It recommends sleep when depleted, social support when tempted, time-inconsistent commitment devices when long-term goals are fragile, and counter-habit training when contexts provoke lapses. The agent becomes a designer of their future self, rather than a judge pronouncing sentence on a metaphysical will. The chapter's third theme, freedom as the ability to act according to one's nature, not outside of it, finds its scientific footing here. To act freely, in this sense, is to act from within a stable configuration of values and knowledge, without coercion or pathology, with sensitivity to reasons and a capacity to translate intention into execution. Freedom is impaired when compulsion, deception, or illness hijack control. It is enhanced when education, health, and social trust expand the repertoire of viable actions. Neuroscience contributes mechanistic details, how inhibitory control can be strengthened, how habits can be overwritten, how stress chemistry narrows option sets, but the normative point predates those details. A person acts freely when the pattern of their action expresses who they are in the reason's responsive sense, and when that pattern is appropriately coupled to reality. They act unfreely when their action expresses a transient distortion, panic, coercion, severe misinformation that breaks that coupling. This notion of freedom is naturalistic and humane. It locates dignity in the functioning of a person rather than in an imagined whole in causality. A critic might object that this collapses freedom into mere self-expression and that harmful natures would then be licensed. The objection trades on an ambiguity in acting according to one's nature. On the view sketched here, nature is not a fixed essence, but a policy learned over time, open to criticism and revision. Social norms and law exist to ensure that one person's self-expression does not trample others' equivalent claims. Holding someone responsible is, among other things, a way of insisting that they align their policy with publicly justified constraints. The more precise the understanding of how such alignment is achieved, through incentives, education, altered environments, the less room there is for fatalism and the more room there is for reform. A violent disposition is not a license. It is a risk factor to be managed with interventions that are as firm as necessary and as respectful as possible. Meaning, too, survives. If meaning required absolute authorship, it would be scarce indeed. Most of what makes lives valuable, love, skill, understanding, beauty, solidarity, depends on reliable coupling to the world and to others, not on a metaphysical spark. A musician's meaning lies in the shaped capacity to translate intention into sound under constraints, in the hours of practice that trained attention and reflex, in the shared standards that make excellence legible. A caregiver's meaning lies in daily acts that reduce suffering and sustain dignity, acts that are no less precious because their springs are causal. To insist that value evaporates when traced to causes is to insist that value evaporates under explanation. That insistence confuses mystery with worth. The hard cases force precision. Consider historic injustice. If actions were caused by culture and scarcity, what do we say about guilt across generations? Determinism does not entail collective blame for descendants. It entails collective responsibility for repair when current benefits are traceable to prior harms and current disadvantages to prior predation. The reasons are forward-looking. Legitimacy of institutions, stability of cooperation, and fairness in opportunity. Or consider risk assessment tools in criminal justice. A causal mindset tempts technocracy, but models trained on biased data embed and amplify past inequities. Here, the science of influence must be constrained by principles of equality before the law and by procedural safeguards that ensure transparency and contestability. Determinism increases our obligations to design systems carefully. It does not relieve us of those obligations. Another tension arises between condemnation and compassion. Understanding a person's causes can sap anger. Anger sometimes motivates protection. The resolution is to disentangle functions. Anger is useful when it energizes boundary setting and signals that a norm matters. It is harmful when it curdles into dehumanization. A deterministic ethics should keep the informational and motivational content of anger. This must stop, and we will stop it, while draining the metaphysical bile that imagines a pure author of evil. The target of condemnation should be the act and the policy that produced it, combined with pressure to change the policy. The target of compassion should be the person as a learning system situated in constraints we can jointly improve. This division of labor is demanding, but it is the right ambition for adults in a complicated world. The practical program that follows is not utopian, it is incremental. In schools, teach self-regulation not as willpower mystique, but as skill, with explicit practice in delay, reframing, and conflict de-escalation. In health, treat depression and anxiety not as moral failings, but as disorders of effective control that respond to combined social and biological treatment. In workplaces, design defaults and feedback in ways that make ethical choices easier rather than relying on heroics. In criminal justice, reserve incapacitation for demonstrable risk and invest in rehabilitation whose mechanisms are open to audit. In politics, reward accuracy and humility over outrage by structuring incentives in media and party governance. Each move is small. Together they instantiate an ethics that works with the grain of human psychology. Seen this way, the narrative turn discussed in the previous chapter is not an enemy of ethics, but its instrument. We still tell stories about what we did and why. The stories change. They speak less of pure choosing and more of learning and design. They include upstream causes and downstream commitments. They acknowledge luck in outcomes and keep the focus on the quality of decisions under information actually available. They emphasize repair over ruin, structure over scolding, and dignity over denunciation. They are not excuses, they are plans. A final worry lingers. If all is cause, where is merit? Where is love? Where is the point? The answer is in the nature of creatures like us. We are social learners who care about reasons and who flourish when our reasons line up with reality and with each other's well-being. We are happiest when we can foresee and shape our futures a little, help others do the same, and belong to communities where norms are fair and fairly enforced. Determinism neither guarantees nor forbids these goods. It tells us where to look to build them and where to stop pretending. Freedom, on this account, is not the power to float above one's nature. It is the capacity of a nature to organize itself around the goods it can understand and endorse, to respond to reasons without a puppet master, to become, over time, more skilled at being what it is. Responsibility is the practice by which we help one another do that work, and when we fail, the practice by which we limit the damage, learn, and try again. When the metaphysics quiets, a gentler clarity can surface. You did not choose your first causes. You will not choose your last. Between them is a span where reasons can still move you, where care and craft still matter, where repair is possible. Perhaps meaning is there, in becoming the kind of pattern that honors the reasons that make lives go better, and in helping others do the same. Chapter 10. Living peacefully with the illusion. If the world is a network of causes in which our actions are the most probable outputs of histories and states, why does life feel navigable only when we speak as if we are pilots at the helm? The short answer is that the experience of willing is an efficient user interface. It compresses the mechanics of decision into a sense of authorship that is computationally and socially useful. We can accept that will, as experienced, is a construction and still live well with it, much as we accept that color is a construction of the visual system, while still trusting traffic lights. The long answer takes us through motivation, learning, stress physiology, social coordination, and meaning. Along the way, a recurring theme emerges: the belief that one can act accurately calibrated or slightly optimistic has measurable benefits for persistence, health, and cooperation, even when the underlying processes are mechanistic. The point is not to worship illusion, but to understand which aspects of the familiar feeling of freedom support adaptive regulation and which mislead, so that we can keep the former and temper the latter. Psychologically, the perception of control supports goal pursuit. Animals and humans exposed to uncontrollable stressors show behavioral and neurochemical signatures of learned helplessness. When contingency between action and outcome is restored, those signatures recede. What matters is not a metaphysical ability to transcend causes, but a reliable mapping from effort to effect that the organism can detect. The first-person feeling that my choice matters represents this mapping in a compact way. It bundles expectations about controllability, value, and effort cost into a felt readiness to act. When that readiness is absent, fatigue and passivity follow. When it is present, organisms invest and explore. Self-efficacy beliefs, expectations about one's capacity to organize and execute actions required to manage situations, predict persistence and performance across domains. The beliefs do not rewire physics. They rewire attention, appraisal, and effort allocation in networks that in turn change the trajectory of behavior. The illusion, if that is the right word, is not that neural computations occur. It is that the voice of authorship speaks before, during, and after those computations and claims the role of origin when its proper role is guide and reporter. A related body of work examines the locus of control, the degree to which people interpret outcomes as contingent on their own behavior versus external forces. An internal locus correlates with better coping and health behaviors, in part because it encourages problem-focused strategies rather than pure emotion-focused rumination. Yet the correlation is not monotonic. Excessive personal control beliefs in domains that are objectively uncontrollable produce frustration and guilt. Here, humility protects. The skill, then, is calibration, not abdication. To nurture a default expectation of influence that is strong enough to motivate adaptive effort, while updating that expectation when evidence accumulates that a situation is refractory to control. The felt freedom that animates action is healthiest when it is porous to feedback. That porosity is a scientific habit of mind adapted to the personal scale. One can object that these findings celebrate a kind of useful self-deception. The charge is only partially right. There is a phenomenon psychologists call the illusion of control, in which people overestimate their influence in chance settings, and there is unrealistic optimism about personal futures that buffers mood but sometimes raises risk. These are errors, and in domains like finance or health, they can be costly. But there is a second, quieter phenomenon in which slight positive bias in perceived efficacy sustains effort through noisy feedback until real competence catches up. A novice musician who believes a little more than the evidence warrants that they can master a phrase practices longer and thereby makes the belief come true. The mind's narrator smooths the jaggedness of early failure and shouts encouragement. From the standpoint of mechanism, dopaminergic prediction errors shape plasticity, while executive circuits regulate persistence. From the standpoint of subjective life, hope says, again. Illusion here is not a lie, but an extrapolation conducted in the grammar of feeling. The comfort that comes from a sense of authorship is not confined to achievement. It matters for health. Perceived control moderates stress responses. If an aversive stimulus is believed to be escapable or predictable, physiological markers of stress, including glucocorticoid release and sympathetic activation, are lower. Expectancy effects influence pain via endogenous opioid and dopaminergic systems. Expectations about relief can reduce reported pain and measurable nociceptive processing, while negative expectations exacerbate them. If one insisted on a picture in which only uncaused choice counts, these findings would be puzzling. Once one sees that belief is a parameter in a control system, they fall into place. The body is a prediction machine aligned by priors. The story we tell ourselves is one of the streams from which those priors are drawn. None of this licenses magical thinking. Calibration returns as a watchword. The experience of willing is most useful when it tracks real affordances and decays under honest error signals. Practices that enlarge this calibration range include mindfulness, which trains attention to the arising of urges and to the space in which they can be let pass, cognitive reappraisal, which disentangles appraisal from raw sensations, and values clarification, which helps organize long-horizon goals so that day-to-day control exercised in service of coherent ends. These are not metaphysical antidotes, but training regimens for a narrator learning when to speak and when to listen. They increase existential resilience, not by promising exemption from cause and effect, but by widening the span in which feedback can be converted into skill rather than into shame or surrender. There is also a social layer to peaceful living with illusion. The sense that others act freely structures practices of trust, promise, and accountability. We ask for reasons and expect them to guide behavior, because reasons are the currency by which agents coordinate. If we were to announce overnight that no one is responsible because no one is uncaused, we would have confused metaphysics with engineering. The engineering problem is to design norms and institutions that leverage the fact that people are reason responsive while recognizing the causal determinants of lapses. In that design, the rhetoric of freedom can be thought of as a user-facing interface to a complex backend. "You chose to honor your commitment" is a phrase that credits the visible surface. Beneath it lies sleep, stress, incentives, the memory of prior cooperation, and an internalized story about who one is. We do not need to display the entire backend at the moment of praise for the praise to be truthful. It is truthful enough to say that the pattern held when holding the pattern was hard. The narrative sense of self that we carry is equally double-edged. On bad days, it overclaims. It tells us it authored what it merely reported. On good days, it organizes priorities over time and keeps counterproductive impulses from steering. Living peacefully with the illusion does not require a purge of that narrative voice. It requires dialectic. One learns to shift between two stances. In the first, the phenomenological stance, one acts as if one's reasons are primary, because that framing harnesses attention and willpower. In the second, the engineering stance, one steps back to analyze friction in the system, redesign contexts, and treat relapse as data. The stances are compatible. The first keeps life livable in the moment, the second keeps it improvable across moments. Moving fluidly between them is a mark of maturity rather than of inconsistency. Some worry that lay people will misunderstand determinism as futility. The remedy is pedagogy that distinguishes between prediction at the population level and uniqueness at the person level, between explanation and excuse, between inevitability and high probability. It helps to point out that learning itself is a causal process. Practice changes synapses and policies such that future actions differ systematically from past ones. The story, then, is not that nothing could ever be different. It is that difference comes from specific interventions, not from bare acts of will. Accepting this tends to make people kinder to their past selves and more exacting about their plans. It also changes the moral tone of self-help. Fewer invocations of inner magic, more attention to sleep, social support, and scaffolding. Paradoxically, as the rhetoric of freedom cools, the texture of freedom warms. Efforts succeed more often because they are better aimed. Meaning is often thought to require absolute authorship, but that requirement dissolves under scrutiny. Meaning tracks coherence, contribution, and connection. Coherence is the alignment between values and actions across time. Contribution is the impact on others' welfare and on projects larger than the self. Connection is the felt and actual bond with other agents. None of these depends on a free will that floats above causes. They depend on reliable coupling between reasons and outcomes. A clinician who relieves suffering does not ask whether her decisions today were metaphysically uncaused. She asks whether her preparation, attention, and care were adequate and whether her intervention helped. A parent who comforts a child does not need exemption from physics to make that comfort real. The child's nervous system settles because a regulated adult co-regulates them. The story we tell about love fits through that causal aperture without remainder. Still, the thought returns in the night. If every act could be explained, does any of it matter? The answer lies in the difference between explanation and valuation. Explanation tells us how patterns arise. Valuation tells us which patterns we ought to prefer and encourage. A mechanistic story about kindness does not diminish its worth. It shows us how to grow more of it. A mechanistic story about cruelty does not absolve. It shows us where to prune. The experience of choosing may be a narrative overlay, but the consequences of choices are not overlays. They are the actual trajectories of bodies and institutions through time. A life lived as if one's reasons matter is a life that, when reasons are well chosen and implemented, yields states of affairs that nearly everyone would agree are better. Fewer harms, more understanding, richer art, sturdier trust. The question of necessity remains. Could a species function without the feeling of freedom? One can imagine an intelligent creature without our narrative voice, steering purely by subpersonal computation and silent models. But our lineage took a different path. Language enabled behavior to be explained and predicted in the currency of reasons. Social complexity selected for the ability to present oneself as a stable agent. Memory stitched episodes into careers. Under those pressures, the feeling of authorship likely conferred advantages. It allowed instructions to be internalized, commitments to be represented and recalled, and failures to be reframed for learning rather than for mere aversion. The feeling may not be strictly necessary for intelligence, but it is fitted to the ecology of beings like us. In that sense, the illusion is not a bug. It is a specialization. There is a danger, of course, that the same specialization inflates beyond its adaptive range. Cultures sometimes teach a heroic voluntarism that blames individuals for structural harms and sells remedies that ignore material constraints. The scientific antidote is to keep the interface but enrich it with backstage knowledge. Tell the story of effort, but also the story of sleep and wages. Praise grit, but also build schools and streets that do not punish the exhausted. Calm metaphysics frees compassion to work on the right levers. You are not letting people off the hook when you ask which hooks are attached to the wall and which to the person. You are making the hook that matters hold. The existential edge of the illusion is gentler than it first appears. Many people fear that abandoning absolute freedom will flatten life, draining praise of its sparkle and love of its mystery. The opposite often happens. Praise becomes more specific. Not you are exceptional, but the way you practiced the hard part changed the performance. Love becomes less anxious. Not prove that your feeling transcends cause, but let your reliable care be my shelter. Humility grows easier. Not I am the sole author, but I am a grateful node in a web that made this possible. Gratitude becomes less superstitious and more abundant. Meaning shifts from solitary heroics toward shared craft. A peaceful life with the illusion retains some deliberate ignorance. In the thick of action, you do not rehearse a lecture about basal ganglia loops before you sprint or console or decide. You inhabit the first-person frame and let the narrator do its work. Afterward, when reflection would be useful, you pull back and ask mechanistic questions and future-facing ones. How did sleep matter? How did framing influence attention? Which cue I can modify next time? The alternation is not hypocrisy, it is skill. The brain itself alternates between exploit and explore, between policy execution and model updating. To live peacefully with the illusion is to map that alternation into the space of meaning. Rituals help. Humans mark beginnings and ends with public declarations, weddings, graduations, eulogies, oaths, where the language of choice is front and center. We keep these rituals because they coordinate behavior and signal commitments. There is no need to purge their grammar. Instead, we can invest it with an honest subtext. I choose can mean the system that is me has learned enough to make this pattern stable, and I invite you to hold me to it. The solemnity does not diminish when translated. If anything, it deepens, because one sees how much scaffolding stands behind the promise and how much patience will be required to keep it. Even the arts can be read through this lens without losing their romance. A novelist's plot is a demonstration of reasons in motion. Characters live because they behave in ways that are intelligible from within. We do not ask whether the characters possess libertarian will. We ask whether their choices ring true given their natures and the worlds they inhabit. Life is not a novel, but readers and writers have long practiced the stance that this chapter advocates. Treat agents as agents for the sake of engagement, and treat them as systems for the sake of revision. Art becomes rehearsal for ethics under determinism. For all the talk of peace, there will be grief. Some losses will feel unendurable, and the knowledge that they were overdetermined will bring no comfort. The best we can say is that the same causal honesty that denies miracle also promises repair in the coin it understands: time, attention, resource, companionship, and design. There's resilience to be found in the quiet confidence that these things move the world, and therefore, at human scale, move the heart. People who have lived with depression or bereavement sometimes report a softening rather than a hardening when they adopt a non-mystical view of will. The softening comes from releasing the impossible task of authoring everything and taking up the possible task of tending what can be tended. At the far edge of these reflections lies a familiar paradox. To live peacefully with the illusion, one must in some moments decline to inspect it. That is not hypocrisy, it is ergonomics. The organism that constantly interrogates its own agency will stall. The organism that never interrogates it will repeat avoidable mistakes. The middle path is a rhythm, not a rule. Act, reflect, redesign, act again. Scientific knowledge informs the redesign. Narrative commitment fuels the act. Between them, a life takes shape that is both honest about its causes and devoted to better ones. The chapters that preceded this one argued that determinism did not doom agency, that quantum randomness did not grant it, that neurons implement the computations of choice before awareness, that probability rides through our lives like grain through wood, that the past shapes us, that consciousness narrates, that many worlds, if they exist, do not rescue absolute freedom, and that ethics can be built from capacities rather than from exemption. This final chapter is not a logical conclusion so much as a practical one. It asks how to dwell in such a picture without chill. The answer is to treat the feeling of freedom as a good instrument, to hold it when it steadies the hand, and to lay it aside when its romance misleads design. The instrument is simple. I can do this next right thing. The design is complex: sleep and structure and solidarity and skill. Between them one can live well enough to keep trying. At the close, there is room for a small, honest tenderness. You are not the first cause, and you are not the last. You are a seam where reasons meet. Let the story you tell yourself be brave enough to face causes and kind enough to keep going. If freedom is not absolute, meaning still is possible in the way your pattern holds, in the way your care becomes someone else's ease, in the way a day can end having made a little more sense than it began. My friend, we've reached the end of this quiet journey through choice, physics, and the mind. If you're still awake and curious, you're warmly invited to explore another video where new wonders are waiting for you. But if your eyes are heavy, then close them gently now and let me wish you sweet dreams among the stars.